Hi, my name's Bob Greenyer and I'm a volunteer with the Martin Fleischmann Memorial Project. So welcome this evening. Thank you for joining me. I have had a pleasure going through some of the things that I've been thinking about over the last couple of years, and I want to add some clarity to that, and I want to give you an overview of one of the key documents that I read. Probably it was either at the end of 2017 into 2018 before I started finalizing the O-Day slides, or I actually think it was late 2016 after I visited George Eagley and prior to me making the connection between cold fusion and ball lightning and the work of Ken Shoulders between late 2016 and early 2017. Anyway, I haven't read this document for a very long time, and in fact I don't even think I read it all through when I very first read it. However, we're going to read through it tonight, but I want to do some grounding before then in some of the things that I've been talking through the week in reference to the presentation that I made Friday a little over a week ago. And that is this whole concept of making and breaking the EVO and what was shown in the very first video from the Vega experimental series from Henk in Holland's Vega experiment. Which I called Evo Blaster, which was shared on 10th of December 2020. And on that same day, there was another video shared, which was a subsequent experiment where the addition of AM radio tuned between stations in the same fashion that John Hutchison used to tune his equipment to listen out for the explosions, the EMP explosions. So that was called Vega EMP. And those two together I thought were the most significant demonstrations of this technology in a visual way and an auditory way to launch off the Vega series of experiments. And we're going to just go over a little bit more detail in there. And then I want to talk about where there are potential energy gains that can come from this system, and also what is actually going on and a hypothesis for that at a deeper level. And this will involve us reading through that paper, which I haven't reread through. You'll see the highlighted sections, which I started as I was preparing for this live stream tonight. But I think it's going to be an interesting journey. And interestingly, during the week, I actually looked at this author to see if he'd produced any other work, and I was absolutely amazed that he had. And in both cases, it looked that he had either seriously studied the field up to the point at which this first paper was produced in 2005, and then he had gone on to look at other research in the field, and he had interacted with the claimants, and that's very interesting. And he gives credit to one of the claimants, at least in the second paper, for deep conversations. And I think this will tie a lot of the various alternative energy over unity technologies together. Now, can people hear me? That would be great. So hi Artifact, hi Anne Beck, hi EBB, hi Glass Chappie, great to have you here. Hi Stephen. Okay, so hi Thor, hi Simeon, hi Corky, excellent. Hi Daniel, we've got a good quorum here. So thank you for joining me. So I'm going to show you the first slide here, and what I've got going on here, if I can switch my mouse over to the right computer, is, in fact, I'm going to do what I said I would do for someone who pointed this out, is I'm going to increase my mouse size. So just hold with me a minute. I go to the accessibility. I don't change the color on their cursor. I'm going to make the mouse a little bit bigger for those people that want to know actually where I'm pointing at. So I'm calling this presentation Make or Break, Make and Break rather, and it's actually the name of the two segments of my Red Pill presentation that was given to the Indian Babra Atomic Research Centre and scientists, former and current, and some students at the Technical University in Mumbai. I think it was on the 3rd of March 2017. And the presentation that I came out for after that was called Make and Break. It was in two sections, and I'm riffing on that today. And what we've got there on the right is the first drawing that appears on the patent here of one Kenneth Radford Shoulders, and it's this drawing down here. And I recommend you get this tome for free and print it out and study it in deep. and it is energy conservation, energy conversion using high charge density. So there we go, and we're going to have a look at that, and I think it'll be very interesting. Okay, so make and break, and so here we have this diagram, and it's being colored up, and we're going to talk a little bit through there. And over on the left here, we have a couple of sentences from the 2010 interview between Nancy and Ken Shoulders. That's Nancy Lazarian and Ken Shoulders and John Hutchison. And just to let you know that Nancy and John have both got COVID at the moment, but they're 10 days in. John is faring better, so I hope you'll join me in wishing them well. Anyway, Nancy is saying here, and when they explode, and she's referring to exotic vacuum objects here, and when they explode, they're gone. And Ken says, in that case, they explode. They break down into lots of little electrons, lots of ions. That's what the flash of light is. That's the ionic spectrum of the explosion, and no more. Okay, so why is this relevant to Vega blaster here, Evo blaster? Well, as you go through this, when one of the Evos, in my belief, like this one up here, okay, when that explodes, if I just step forward there, you've got an explosion. It's a hemispherical explosion, and it's intensely bright white. So I've described this on my blog here on remote view, and I'm just going to walk through this, and then you'll see where I'm coming from. And no, I didn't do it there. I did it in the Xeno. So we have this Xeno project here on quantumheat.org. So obviously it's a riff on Xenon. And the live document is in there, and that's where stuff is going. And I have, if you click down on the underneath this document here, you have view, edit this document in full screen. And if you click on that, it'll give you access to the full document here. And I'm just going to read through this EVO make and break cycle hypothesis. And this was sort of just quickly dumped into the document. I think maybe by the end of reading these other papers today, we might have some more clarity. But anyway, at one point, Ken called exotic vacuum objects charge clusters because they are charge clusters, but joked that a speck of dust qualifies too. In them, he established that exotic vacuum objects can carry one ion per 100,000 electrons. And in fact, that is in this document, and you can read that exact statement there. They don't have to carry an ion, but if they do, it makes them more stable. And so you can get, say, 10 to the 23, say, electron densities. It's not actually 10 to the 23, but the relative ratio would be, if you had 10 to the 23 in a collection of EVOs, you would have 10 to the 18 ions. Okay, so transmutation can occur inside if it is from heavier isotopes. It will require neutrons to decay. This will produce electrons. If you start with 208 lead, for instance, and end up with 17 carbon and change, which is something that Takaaki Matsumoto did in his 1997 paper, you will have produced a good number of electrons in the process. If you collapse matter entirely into light and leptons, as indicated by 1979 work of John Hutchison, the 1992 work of Solin, the 1990s work of Matsumoto, and the 2000 work of Adamenko, you get much more of what you are after to do work. The charge can change in the exotic vacuum object 1 billion to 1 easy. That's a sort of quote paraphrased from Ken Shoulders. But as we found in Lyon and Matsumoto found, and Shoulders and Russian energetics researchers, the ions and electrons act like a single charged entity and can move along wire in the direction of the normal charge movement. When faced with a little reactive load inductors, they can fall apart also. And when they do, as we saw in Amasa gas on the 10 yen coin, and in Ritskev, as Ritskev saw in exploding foils, they can split into microball lightning structures. So they can have a substructure. So when Ritskev was exploding his wires in that seminal paper that I've referred to a good number of times now, it produced a ball lightning above the chamber, and then after a few microseconds or milliseconds, the ball lightning split up into little smaller ball lightnings. I think Tucanoff has seen similar things, and we obviously observed that in a Mars gas. You had the main plasmoid, the yin-yang structure, that broke away into a little one, which is the sort of monopole one that I referred to, and in one side of that, we had the snowballs on cobblestones. The snowballs gathering up the oxygen from the copper oxide and synthesizing sulfur. So that gives you an idea how it's self-similar and it can break down into smaller units. Okay, and so how this happens, this also happens when they hit a metal, and especially an anode. In the Vega videos, the event occurs actually on the cathode. So this here is the cathode, this is the anode. So the idea, as I said before, was this is potassium hydroxide coated tungsten, and those are two promoters of what you want to achieve. And this produces some EVOs. You can certainly see the production of fireballs on the anode, but I believe that some small ones are being made either here or on the cathode, and they are migrating to other places. But whatever, there are EVOs that are being produced, and then when they explode, you have these extremely violent spherical explosions. And if I step forward again on this video, we'll see it leaves a black splodge. So I'll go back one frame and another frame. So there's nothing there, right? A point there. I'm going through 1/60th of a second forward. And then we've got a flash, maybe 1/30th of a second. And then we let go. Then we get a completely black spot. And so I'm going to describe what you are seeing there here. Right. Blah, 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 blah. At these times, they can fall apart and they need to grab thermal heat to reconstitute and get back to equilibrium with their surrounding ions. And in doing so, they become normal electrons and the ions become atoms. This leads to the observed effects on the Vega video in the two videos first made public from Vega experiments on December the 10th, 2020. Vega Evo Blaster and Vega EMP. So, in this Vega Evo Blaster, you have an explosion with sound. This was dishevelment of the Evo at the cathode, a metal and impedance mismatch with abundant electrons. It's a metal, so it has abundant electrons, and it's also the cathode, so there we go. Even though the tank is in vacuum, or not high vacuum, but in vacuum, there is a loud audible ping associated, showing the violence of the disheveling of the EVOs. And this is Vega Evo Blaster. The EVO's coherent matter becomes normal matter. The electrons and ions become respectively negative and positive charges, and repel near instantaneously, instantly, coulombically. So this is a coulombic explosion. So what we are seeing here is an EVO is here, and it explodes instantaneously, and it leaves this dark patch. Okay. As the electrons and ions re-emerge into the normal world, they must regain their thermal equilibrium with their surroundings, as they have nearly no temperature because they gave it up as EUV and soft X-rays during formation. They instantaneously cool the wall of the reactor cathode, turning it black. Vega Evo Blaster. The possibly completely ionized nuclei start capturing electrons. Subsequently, those electrons fall through the shells to rebuild the normal atom structure. Though the atoms coming out may not be the same as those that went in, or they may change during the violent unpacking of the EVO. This unpacking word is the word used by Shishkin when he has the string vortex solitons, the neutral, the black EVOs blowing up on his film. The unpacking of the EVO. This reconstitution produces an intense hemispherical burst of light. So what you're seeing here, if we step back, is in one frame, you have all of the electrons and the ions disheveling from the cluster, and they are moving out spherically because of coulombic repulsion. And the ions that are in there, which are 1 in 100,000 electrons, they are capturing some electrons either from the surface of the cathode or from the electrons that are released, probably not, or just from electrons from the environment. And that is causing those ions to have the electrons falling through their shell structure and emitting intense light. And so you get this flash as it occurs. So there's that kind of almost instantaneous thermal burst that you saw, that little jump up in the Lion reactor. And then the bulk of the effect is cooling down. So there's an instantaneous kind of a photon-based heating because you've got all this light coming out, but then you have this instantaneous cooling. So it's like a two-stage effect. There is no burning going on. It is all at the individual atom and electron level. So you see a completely spherical explosion with no pieces flying away from anything ordinarily burning, with the exception of things moved by shockwave. And it is an extreme shockwave. In fact, since there is nearly no oxygen in the reactor, burning in an explosive way is largely ruled out, though some might say, what about thermitic-like reactions? And that's Vega EVO blaster. The cooled areas of the tank are observed to slowly get back into thermal equilibrium with their surroundings from the outside in. If it was a deposit and the temperature of the reactor wall had not changed, which it could possibly be from synthesized carbon, say, one would expect it to fade away evenly and not from the outside in. So let's hope I'm right here. So let's watch this one here. I'm just going to step forward. So we have our black circle here, and as we step forward, that cold black circle, in theory, will get progressively smaller as thermal energy is conducted from the surrounding chamber wall, until it's difficult to perceive the original cold spot. It gets there eventually. And I'm going to speed forward. There we go. It's almost there. It's almost there. And then we've got something that's changing the camera's optics. Okay, so it's very small now at this point. Okay, let's step forward. Yeah, it's pretty much gone. Anyway, there we go. So that is the kind of look at what's going on there. Now, in the case of the Lion track here, and there's a blown up one here, and in fact, when you look at my blog here, it's the actual image here is that. Yeah, so in the Lion track, it froze this Cu2O, and these are the EVOs unpacking, and in unpacking they produce an incredibly cold area instantaneously around them, but they also produce a lot of electrons, and the electrons are in the ratio of 100,000 to 1. So if we go back to where was I? I was not here. I was here. Maybe I don't know whether I say that. Do I say that? Maybe I didn't say that. Where is that? Oh, I've lost it now. Oh dear. Anyway, it's in there somewhere. Okay. Anyway, so I also added in here the discovery of a new kind of electrical current by Matsumoto, and some references from there. And a new kind of electrical current was observed as the flow of these tiny ball lightning. And this was for a discharge between two electrodes. And he also says somewhere here that he found... okay, so Here, elements of potassium and calcium were confirmed by EDX. Since potassium was the electrolyte element, this fact obviously indicated that the itonic hydrogen clusters containing potassium ran along the copper cable wires, but inside the coating films, and the element of calcium should be transmuted from potassium in the itonic clusters during the transmutation. So you could argue that the calcium could be coming from potassium 40 through beta decay, or that a proton is going into the potassium in the process as it's carrying along. Anyway, this indicates that transmutation is occurring in the ball lightning, and if that's doing that whilst it's traveling along the wire, then the energy will be doing something in that process. If it's a beta decay, then obviously you've got this high energy 1.551 mega electron volt beta coming out. If it's a proton, you're still going to get energy coming out. So you either got an electron coming out at speed, and if that occurs, for instance, in your gas chamber, then that can do a lot of ionization. But anyway, this is sort of confirming that the ball lightning is doing transmutation, and we can talk about that when we're talking about the type of things that can go on in the Xeno type experiments. Okay, so sorry, it's actually in the Xeno document, isn't it? So the cooled areas of the tank are observed to slowly get back to thermal equilibrium with their surroundings from the outside in. If it was a deposit, then the temperature of the reactor wall had not changed, which it could possibly be from synthesized carbon. Say, one would expect it to fade away evenly and not from the outside in. So that's just repeating that. So because there is emergent, fast-moving, charged, biased at a ratio of at least 100,000 towards electrons, moving at incredible speed spherically. Regardless of their thermal state, there is a scalar electromagnetic pulse which is able to travel through thick mild steel reactor enclosure and be recorded as pops on AM radio tuned between stations in sync with the visual flashes. And this is what we saw in Vega EMP. Okay, so with these two videos that were shared on the December 10th, 2020, I believe we've demonstrated the violent unpacking of exotic vacuum objects, and I believe that the second video with the EMP, with the pops on the radio, we've shown that there is an abundance of electrons in that process, and that is what we are looking for, because if you remember in the Lion reactor, when these unpacked, they produced electrons, and the electrons lit a 20-watt halogen bulb for about 30 minutes. And so that is some kind of way of storing power, although it's very destructive to the material that it was stored in. And but anyway, you can get an idea of the amount of power that's stored in these things. Now, when Shishkin is talking about these things unpacking on X-ray film, its electrons and ions come out, and I can probably go to that. Have I got that presentation? Yes, I might do. Just bear with me 1 second. I will find that presentation. Okay. Is everyone happy? Maybe I haven't got that here. I will go to the YouTube video. Bear with me a second, my friends, and I will just get something here. Nearly there. Okay. So this is Alexander Shishkin's A New Type of Penetrating Radiation. And in it, he observes these birdies. And the birdies were also observed by Perovskikov and by Bogdanovich under different circumstances. When I go to them, when I'll find them again. What happened to them? I just had them. There we go, somewhere there. Okay, so there we go. These are these birdies, and these are the lion paw prints, in my view. They are the same structure. And this, he says, is the explosive unpacking of string vortex soliton. And it's like a mushroom, Perovskikov calls it. And these are the magnetic monopoles of Roitzkiev and of the Bogdanovich team. Okay, so what he found on the X-rays also were these pits. And these are the ions that are shot out. So you have electrons spraying out and you have ions that are shot out. And when they investigated and found that the depth and the width of the pit was directly corresponding to the atoms that had been captured and effectively teleported out of his cavitator. And at one point here, he talks about, if I can find it, the different methods for generating. Okay, so all of these methods will generate strange radiation from hydrodynamic generator. So this can be, one of these hydro generating thermal devices. This can be a Leclerc device. From revolving bodies made of various materials. So if you spin something fast enough, you will produce these things. From materials irradiated with gamma radiation. So something that's exposed to gamma radiation. And this is exactly what was tested by the Bogdanovich team using a linear accelerator. They accelerated some electrons to extremely high velocities, hit them into conversion targets, something like tungsten, and that produced gamma rays, and the gamma rays then went through some magnets, and the magnets then caused the production of both north and south magnetic monopoles, these birdies, and they observed them to be exactly the same structures. From gamma sources, 60 cobalt and 137 cesium. So John Hutchison would often have some uranite in his experiments, and obviously uranite has uranium-235, which decays, producing some 137 cesium, and so he would be producing, just by having it there, he would have been producing these birdies. And also in the PAP engine, he used either a radioisotope or he used corona discharge, which will produce these things. And you can see that down here, from a reactor producing a corona streamer discharge. Corona streamer discharge. We're going to see someone, Lord Raleigh, work in the 1930s discussed in this paper in a little while. And also this is the corona discharge that Tom Claytor found produced tritium. So it was doing the Lehner effect and producing charge clusters. And it's also the corona discharge that has been used by Savatomova over many years. Most recently shared at ICCF 23, where she was synthesizing nickel-61 in abundance, and that is something that I observed on aluminium from John Hutchison. And so corona streamer discharge, and so that is one of the methods that John Hutchison used effectively, and with cesium-137 from uranite, that would also be a method. By applying a high voltage pulse of plus or minus 590 volts on X-ray film of an opaque package located between plates of flat capacitor with an 8mm distance. So this is one way of doing it. And from generators, so there's two generators down here. So there's a whole bunch of different ways of doing it. So thank you for bearing with me as I dug that up for you, and you can go and have a look at that in your own time. Okay. So what I'm saying is these structures, they can make a macro structure. The macro structure can break down into little structures, and the little structures can travel along wires. They can transport elements with them. They can transmute those elements. We've observed that in the Marsa gas on the 10 yen coin. And in fact, I have shared in the past in the lion copper on the outside, you saw these paisleys, which are these ball lightning traveling along and carrying a different material. And I believe that that was silver that it was transporting along the wire. And it's similar to what was being observed by Matsumoto. Anyway, so I've seen all the evidence I need to see. It's just about whether other people can accept it is a different matter. Okay, so I will go back here. Okay, so where was I? Yeah, so what Ken has got here in this paper is he's put a negative pulse through the input here. He has a current limiting input resistor. He has a spike here, which is the EVO launcher, the cathode, and it goes along here. I believe I can't, without reading it, I think this might be a ceramic guide, because if you have a sort of dielectric or whatever, it likes to travel in a channel, and you have a waveguide in there that's the right dimension for the type of EVO that you are knowing to be producing. And it travels along here from the cathode to the anode. Now, there is a ground biased area here which kind of holds it down, and then it's got a helical coil around here. Now, what you are seeing here, in my view, is kind of like the PAP engine. So you create your charge clusters down the bottom here using your radioactive isotopes or other means of ionization. They are ready to be blown up. You blow them up with a spark discharge, and he had a toroidal cylinder head which would force a large soliton to travel up the chamber, and because it was ionizing things as it came out, and you've got the gas, the electrons falling down through the shells and also producing lots of photons and so forth. You then had the charge moving up in a toroidal fashion, and it produced an EMP and a magnetohydrodynamic effect. Anyway, as the soliton travels down the chamber here, it is coupled, and it's coupled in such a way that this is a resonant chamber, and the helix here is well designed, and it's actually quite well discussed in his paper, which I've got over here on the right. Maybe I'll read some of that later if we can get to it. But anyway, then you have an output here with a collector resistor, an output terminal. You also have a load here, so you could put a load that is taking the power from here. And in fact, I think if I read the section here, I think he's saying the velocity of an EV is typically 0.1 the velocity of light. You know what? That is exactly the same as is reported in that international collaboration that I talked about with a laser pulse into plasma. So the velocity of an EV is typically 0.1 the velocity of light, or a little greater. Exactly the observation in that paper. And this is from a single pulse. This isn't resonantly pumping it. This is a single pulse, just like the laser individual pulse in that paper. And this speed range compares favorably with the range of delays that can be achieved by a helix and serpentine delay line structures. For example, the length of the helix 564 here, the length of this helix, and the EV path from the launcher or cathode, the launcher of the cathode here, 552, to the anode, 556 over here, may be approximately 30 centimeters. So this here to here is 30 centimeters, with the helix so constructed to achieve a delay of approximately 16 nanoseconds at a helix impedance of approximately 200 ohms. So this is 200 ohms helix here. This is 30 centimeters and so on. The impedance and delay of the helix 564 are affected in part by the capacitive coupling to the ground plane 558. So you've got capacitive coupling to this ground plane here. The inside diameter of the glass or ceramic tubing 554, this is this glass tubing here, it may be approximately 1 millimeter or smaller, with the tubing having an outside diameter of approximately 3 millimeters. An exotic vacuum object can be launched at a voltage of 1 kilovolts, determined primarily by the source. So you've got your source down here, launched from the launcher. At a xenon gas pressure of 10 to the minus torr. Okay, so this is 10 to the minus torr in here. He's using xenon. He's ordinarily typically using tungsten. The thing about that is it's much lower pressure than you have in a typical xenon HID tube. The ones that are pure xenon will have a much higher pressure, something like 15 bar, and if they've got mercury vapor in there, the initial pressure is 5 bar, and this is something to bear in mind for safety, because if you've got 15 bar, that is an explosive thing. The mercury will, when it's ionized, increase the pressure anyway, but when they're cold, they're only, I think, 5 bar, those ones, or certainly less than 15 bar. So anyway, that means you need to be a lot closer. You need a much shorter arc, and so you can't achieve the kind of length of arcs here unless you have much higher voltages if you are running at the higher pressures. So these are things that are well understood. Anyway, so a xenon gas pressure of 10 to the minus torr to achieve an output pulse of several kilovolts. From example, from the Helix 564. So you've got a 1 kilovolt pulse in here. And then as the EVO travels down here, you get a several kilovolt pulse coming out here, induced in this traveling wave conductor. And then it says, as an example, with a mercury wetted copper wire at a cathode in place of the launcher 552. So if you have a mercury wetted copper wire, a xenon gas pressure of approximately 10 to minus 2, an input pulse of voltage of 600 nanoseconds wide at 1 kilovolts with a firing rate of 100 pulses per second impressed through a 1500 ohm input resistor with an anode voltage of 0 and a target load of 570 of 50 ohms. An output voltage of minus 2 kilovolts was achieved on a 200 ohm delay line, 564 and an output voltage into the target 556 of minus 60 volts. So you've got minus 2 kilovolts here, and you also got a minus 60 volt pulse over here. Okay, so what I'm saying is that he's very detailed, and what I've been reading from is down here, and it's on page 44 or column 44 in his patent. So I really recommend you go and read this patent. There's all kinds of embodiments in there to do various different things. And so that is the rough kind of thing here. So you're able to drive a load here, and you get something out of the tail end here as well. Okay. Now I'm going to talk about another embodiment in here, which is using photoionization, which is a later idea as far as I understand from Ken Shoulders. But before that, I am going to talk about reactions. Now, what you heard in Ken Shoulders' patent there was the use of tungsten, typically, xenon. He also mentioned copper and mercury, but typically he would use tungsten, mercury, and xenon. And in fact, that's what is in the lower pressure tubes. Of course, the electrodes are much closer together. If we were going to do a traveling wave tube inside one of those, the EVO would not be traveling a very long distance. So it's not really appropriate. So you're having to work with it in a different way. You're having to try and create those exotic vacuum objects instantly, making and breaking them. Making them and breaking them. Okay, because you might want the transmutation. And so what have you got which we can use within those materials? So firstly, let's have a look at the element data. Okay, so if we go into nanosoft.co.nz and we go down to mercury, what do we have? Mercury, Hg, HD there. Okay, so It's just shy of the heavier stable element, which is, some people say is bismuth, but that's unstable, but technically it's stable, observably stable. Lead and thallium. You don't want to be dealing with thallium, so let's take mercury. Mercury's bad enough. Anyway, that is in these bulbs. And you can see here, basically every isotope of mercury is stable. Now, if we go down to tungsten, we know, and I have spent a lot of effort over the last couple of years, particularly on my blog, talking about different experiments that observe tungsten falling apart from the work of Langmuir in the 1910s, all the way through the observations of David Hudson, and through the observations of I'm going to get it in a minute. The Sapphire Group saw it more recently. We've seen it, but also Mizuno saw it and published that in 2006. Anyway, so it's been observed by many authors, and I'm going to go back to the thing here. So tungsten has one sort of alpha unstable isotope, which is 2.5, but we know from our Marsa gas and from other testing that there is a lot of things that can fall apart with tungsten. Okay, so I expect we'll get a lot of energy out of that. That's my hint. But what else have we got in there? Well, we've got xenon. So let's go and have a look at xenon. Xenon 54 there. Now, the interesting thing about xenon is that its heaviest isotope, 136, okay, is a double beta isotope, okay? And that produces 2.462 million electron volts, okay? That if you wanted to ionize things, might be very, very helpful as those two betas are flying out, producing a division of that energy. So it's already beta unstable, and that is not a small percentage. It is 8.87% of natural xenon. So already we have this potassium 40, which we know decays beta with the influence of these things from many experiments. And we have this, and in fact it's in Parkhomov's book. He says it is the fuel of the future, potassium 40. But here, Now, the actual half-life of xenon is scary big. The xenon 136, if you go and look on Wikipedia at the primordial half-lives, this ordinarily would have a half-life of 150 billion years, okay? But as far as I'm concerned, when it's in the EVO, forget it, it's over. There's no stability there at all. But you have all these other isotopes as well. So, what can we get from fission reactions? So I'm going to run this query here because a lot of people ask me how you use this particular system here. So we're going to run it. We're on the fission reaction table here, and I'm going to type in here, if everyone can see it. I'm going to change this to in because I want to have a group. So elements in this set, I want to have. What have we got? We've got our lightest is xenon. Then we have. What do we have? We have tungsten, and then we have mercury. Okay, and then we also want. Are we just fissioning here? We are just fissioning. We are just fissioning. Okay, so we're just fissioning here at the moment. I'm going to drop this here. Just get rid of that. So it just gives us the results. I'm going to leave neutrinos on, and so okay. So let's see what we get. So this is fissioning reactions. Okay, I'm just going to maybe come down a bit. Can we see it? Right, so we have a neutrino involved on the right here, and this is with mercury 196, and we get xenon. Oh, we get more xenon. We get the mercury fissioning to xenon. Excellent. And we get 116 million electron volts, okay? Again, mercury with no neutrinos involved. We get calcium and neodymium and 90 million electron volts. And then we got tungsten 180, which is the rare 0.28, I think, percent isotope. We get titanium 50 and tellurium. These heavy isotopes will fission again, because I'm saying the xenon does. Mercury, tungsten, tungsten, and these are all huge mega electron volts. Now, if we take the xenon 136, we've already yielded from this mercury 196 116 million electron volts. Let's see if we can find xenon 136 down here. Where does xenon 136 come in as a fission? Is it going to come in? Is it going to come in? Is it going to fission? Not everything will. Let me look for 136. It's probably the fastest way to do it. 136. So it's there. It's a product in all of these different. So it's a product in the mercury reaction here, but we tungsten. Lots of 136s coming out. But have we got any input 136s? Maybe. No, it's not a fusion. Fission rather, but we might find that it is a fission reaction. An exchange reaction with other elements. Anyway, to give you an idea, that was just to show you that you have some highly energetic reactions possible even on the first pass. And then these reactions can go on. Now, what I find interesting is whether you're looking at mercury or tungsten, and if you look at the xenon down here, you get cobalt here as well. You've got cobalt up the top here. These calcium, vanadium, titanium, silicon, but a lot of them are calcium. So, if we've got a lot of them being calcium, if we had some spectrometer looking at that, then maybe we will see calcium lines. If we see calcium lines in our xenon HID tube, then we know we must have created exotic vacuum objects because there's no calcium in there to begin with. Okay, so one way is to use a spectrometer to see if we can see the calcium lines coming out. And in fact, Ken Shoulders said that you can get, he said, I'd have it in this little thing and then I would go bzzzt, and then I'd see all these different lines. He says, this was very pure. It starts off with very pure. I knew there are 100% pure elements in there, and I just go bzzzt, and then I've got all these different elements. I go bzzzt, and there's even more elements. I go bzzzt, and then there's loads of elements. And so one way we can see if we are achieving the right sort of regime of stimuli is to see if I would predict that if you are using a low pressure xenon HID tube, that really rather quickly you would see lines for calcium or for silicon or for magnesium or for chromium or for titanium. So it would be worth calibrating your spectrometer to look for something like calcium. And the only problem I will say is that xenon and mercury produce so many lines between them. Xenon, mercury, and tungsten produce so many lines between them. You're gonna have to work hard to see some specific lines. So is there any? Okay, we got sodium lines. We got sodium being produced down here. It's not preferential. We got some sodium here and some sodium here. Okay, so you can look for that very strong sodium line potentially coming out of it. So you would imagine that there would be a change of spectral output over a period of time if you had achieved the reaction. There is no nuclear reactions involved in EVO reaction. That's interesting, Axel, but that's not what Ken Shoulders says. And certainly we've observed things that look like nuclear reactions. Ideally, you wouldn't want it to occur because you don't want your reactor to blow up. But I think you will see them. And don't worry, it doesn't need to be a lot to produce a lot of energy. Anyway, there we go. I don't think you'll see the nuclear output of those reactions. You won't see the nuclear products unless you push it very hard. But there we go. So this is one way. So you've got potential beta reactions. You've got potential fission reactions. And then maybe if we look at exchange reactions. So I'm going to go to a 2-to-2 reaction table here. So there's one way to find out whether you're getting nuclear reactions or not is to have your spectrometer trained at your experiment and see if you do see these lines appearing. If you do, then something's happened. If you don't, then nothing's happened. And that doesn't necessarily mean it won't happen. It just means it hasn't happened. Okay. So observation is always king. If it's there, it's there. You can argue if it's there, but if it's there, it's going to be there. Okay, so order by, I'm going to remove the limit here. So what I've done here is I've gone to 2-to-2, And I have put in E1 is xenon, tungsten and mercury, and the E2 is xenon, tungsten and mercury. And we're going to hit the execute query here. And in theory, if we're lucky, when it comes back, we have some results. Yes, so it's actually got so many results, it's just stopped at 1,000, which is the limit. So you might want to just do xenon and do pairs of reactions and come out. But you can see here that the exchange reactions are much less energetic, but you have xenon and mercury involved with the first major groupings, and they are producing typically these elements that are in the lanthanides. And so these, actually, the interesting thing about these elements here, dysprosium and erbium, is that if you end up having some oxygen produced and these elements are actually extremely good at downsampling their oxides and their compounds of their oxides, downsampling the soft X-rays and EUV that are output from the forming exotic vacuum objects. And so you could end up with increased brightness because there's transmutation going on. That's just something to bear in mind. And when I say increased brightness, I mean increased brightness in the visible spectrum. And so that's something to bear in mind. But still, you're kicking out a sensible 21 million electron volts. And if we remember, I think our ionization, first ionization of xenon is something, I don't know, something around 12.5 electron volts. So you can imagine that this is doing a million electrons, getting on for 2 million electrons could be ionized with the energy that is released here. Okay, so there's a couple of ways that if there was nuclear reactions going on, that there may be some energy gains to be had. Okay, is everyone... There will be no neutrons, Axel, and the gamma radiation is trapped in these are reactions that are occurring inside the exotic vacuum object, and the gamma ray comes out and it's divided in the coherent matter, and the energy is lost in soft X-rays and in EUV. So, okay. And actually, Preparata said it in his book a long time ago. I only recently found that out. So, yeah, it's the coherent matter that does the job. Okay, so I'm going to go and read this paper. But first, what I'm going to do is I'm going to give you the link. So you can read along with Bob, if you want to do that. So let me pull up this, if I got the right thing. And I have it here somewhere. In the mail. So mail. I'm going to get you a link to the paper and you can read along with Bob. Hopefully. Right. Okay, so it's this one. And the paper, well, you can see it in a minute. Here is the paper I would like you to read along with me. This might get boring for people that don't want to read it, but I think this paper... wasn't it very, very important paper for me to read earlier? It was from someone, particular researcher. I didn't know who they were, and I was very early into this. But having this in the back of my mind gave me the tools to see the wood in the trees. Yeah? So here it is. Go and have a look at it. And I will pull it up here. So it's classically bound electrons, exotic vacuum objects, exotic chemistry, and cold electricity. Abstract. And if you can see it, there we go. So here we go. Classically bound electrons, EVs, exotic chemistry, and cold electricity. And this is by C.P. Karoupoulos. And I assume that's a Greek name. I maybe shouldn't assume it's a Greek name, but it looks like a Greek name to me. So some people say everything looks Greek to me, but this is actually... Greek, I believe. Okay. Okay. Abstract. At a range of 10 to minus 13 meters, the magnetic field of a classic point-like spinning electron reaches 1 gigatesla, which overcomes the electrostatic repulsion of another electron. This allows them to pair into singlet states. Dense electronic stringy loops, as well as induce an exotic chemistry and nuclear reactions. The resulting electronic strings shrink. Convert a fraction of their mass into ionizing radiation. Let me read that again. Convert a fraction of their mass into ionizing radiation and thereby generate electrical power by the photoelectric effect. Such a state, upon entering an anode, may use the latter's electronic thermal energy to convert itself again into free electrons, creating the effect of cold electricity. May use the latter's electronic thermal energy to convert itself again into free electrons, creating the effect of cold electricity. A similar process could well be occurring inside conductors. More realistically, fully relativistic, semi-classical evaluations are given in the appendix. In the non-relativistic regime, the potential energy for the two classical electrons can be written as blah blah blah. We're not going to talk about it. Where the magnetic moment, the Bohr's magneton, and G is its gyromagnetic factor. Anyway, the energy, while dominated by electrostatic repulsion at large distances, cancels and becomes attractive at distances below 10 to the minus 13 meters. At such distances, however, this rule no longer applies as written and must be replaced by either the Bergman-Mikl-Taligdi equation or its equivalent in the Vega-Bohm relativistic hydrodynamic theory in classical mechanics, or by some solution to the Dirac equation. Now, you might have seen the Russians debating my presentation that I gave them about the classical hydrodynamics after I gave my last presentation to the Russians, and this is what it's about. But I believe this is absolutely key because I see these hydrodynamic, in this case magneto-hydrodynamic structures occurring in almost every linear system that I look at. This has consequences in quantum chemistry, as two electrons with opposing spins can form a bound quasi-particle state. This is you'll see in a minute, of charge 2e and mass 2m, as suggested by Animu, Malu, Santilli, and Aringazan. Sorry, I'm probably crucifying these names. I apologize to those people. Such an entity has an autonomous existence in the vacuum, as evidenced by the tunneling of Cooper pairs between superconductors, while its consequences in chemistry are atoms and molecules shrunk beyond the usually recognized ground state associated with single electrons. A ring of K closely bound electrons has a Bohr radius of 1 over K squared and a bonding energy of K to the cubed times that for a single electron about a nucleus. This allows for neutral hydrogen polymers with K protons. The corresponding bonding, transitional energies and molecular mass may well have been observed by Randall Mills in the blacklight process, with particularly strong peaks for K equals 4 and K equals 2. The formation of strong negative hydrogen ion, hydrino, can proceed simply with atomic hydrogen, which provides both an electron and the first ionization gap of 13.6 eV. But it's facilitated by a catalyst tuned to the second 81.6 EV gap, such as lithium to lithium 2+, potassium to potassium 3+, 2 neon 2 to argon 3, and 3 rubidium 2, etc. Or having an energy of ionization slightly lower, such as helium to helium 2+, because this liberates more electrons. A hot tungsten, gold or platinum wire is useful in this respect, as it both generates atomic hydrogen and free electrons capable of forming negative ions. Okay, so blah 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 blah. This is one thing that I want to we've talked about this in the past, but this is really where your corona discharge, where the Carrere brothers got their ideas from, in my view, and it produces these. As I showed you in the Shishkin et al. Work, it produces these birdies. Okay. Lord Rayleigh had first discovered that this novel source of energy in low-pressure gas cells, hydrogen, nitrogen, i.e. nitrogen with no hydrogen, oxygen, that is
oxygen with no hydrogen, between 1935 and 1946. You do not need hydrogen. 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 Are we there yet? And had published his findings in the Proceedings of the Royal Society of the Sciences. The energy that can be extracted from a molecule of hydrogen, in this case, in this way can be as high as 200 electron volts. 200 electron volts. So what is that? That is about 18 times, is it 18 times the ionization of xenon, first ionization, anyway, which is dozens of times that from its combustion. Which I think the combustion is, H2 is 4.2 EV. That's not combustion, so H2O, H2O, it's around that sort of level per atom. So it is lots of times more. In the realm of solid state, a semiconductor carrying current creates charge loops of magnetic flux near its surface, which organizes bound electronic strings. These experience a centripetal Lorentz pinch and therefore tend to move just below the surface. A balance between the centrifuge attraction of the charge-depleted surface and the centripetal Lorentz force then establishes itself, the radially opposing blah, 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 blah. Anyway, when a cold cathode is fed with a pulse, the closed magnetic loops come electrons leave it in the form of metastable electronic vortices, or electron valerium, or electron valere, which is strong electrons. These were intensively studied by Kenneth Shoulders and typically contain n equals 10 to the 8 electrons in a region of about 1.5 micron radius. At an average distance of 2 pi r over n is approximately 10 to the minus 13 meters, which is in the attractive range of the potential which was discussed up here. Anyway, okay, so this paper's really rather nice. It goes into how they formed. I don't know whether I want to read it all. Like I say, I haven't read it in years, but let's see. If it's boring for you, let me know. If it's boring for you, let me know. Okay. Is there any problems? I think it would be a bunch of smaller bangs, blah, blah, blah. Okay. So how are EVs formed? Anyway, yes, some funds notice we're very close to 4,000 subscribers. So if you know someone that needs to subscribe to a channel, they have a burning desire to subscribe to a channel, let's get there before the year's out. It'd be great if you can help me. Anyway, how are EVs formed? They are most likely the result from a runaway magnetization that initiates at the density of matter from closed flux ring Landau states enclosing a decaying current. Then a runaway ionization and magnetization ensues that strongly confines and further polarizes the resulting ions magnetically, resulting in denser and denser self-magnetized Landau states. In any material medium, an electric field E near the ionizing threshold excites the atoms and results in the increasing permittivity, that's the symbol for permittivity, that epsilon, that decreases the electrostatic and transverse electromagnetic spin repulsive energy. In a semiconductor such as indium antimony, besides an initial permittivity of sigma is approximately 10, electrons have very low effective mass, 0.014 MeV, that increase their magnetic moment to a lot. And spin-spin coupling to this, while lowering the magnetization needed for Landau states to 0.2 of a Tesla. Their magnetic, and as we've already found in the tests that were done in China, both in laser and stimulation, they're producing, the solitons are producing magnetic forces at 46 microns wide that are 1,000 Tesla and go up from there the smaller they get. Their magnetic field, combined with the electric field at the cathode, then induces the runaway ionization and magnetization of neighboring atoms. There we go. the runaway ionization and magnetization of neighboring atoms, which substantially increases mu while sending permittivity to infinity. The atoms are initially as closely spaced as 0.66 of an angstrom. At some point, the runaway begins in which the magnetic field is enhanced from the emptying atomic D and F shells. Is enhanced from the emptying atomic D and F shells polarized by the exchange interaction. Why is that statement important? That statement is important because xenon and mercury and tungsten have D and F shells. I think, yeah, they do. They all have D and F shells, whereas hydrogen doesn't, okay? Whose magnetic binding to the forming EV surpasses the initial atomic binding energy. The recently discovered phenomenon of ballistic magnetoresistance, which reaches a record 3,000% within the atomic scale nano domain of a tunnel microscope like blah, 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 blah. So he's got a hypothesis here. I believe related to deep shell atomic magnetism of such Landau states, blah, 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 blah. Okay. It then becomes energetically favourable for half the electrons still in the filled D and F shells to leave them and either move to higher empty shells, thereby increasing the magnetic polarization more than twofold, or to form new valence pairs, As the atoms shrink to ever more magnetized and densely packed ionic states, the free pairs form collectively bound molecular orbitals. Now, this is very close to the thinking of Mashinsky in his spin nuclear electron condensates. Soon, which I've talked about in the past, and you can go and look at my SNEC videos on that. Soon, the intensity of the magnetic field induces the valence pairs to start breaking into spin-aligned free electrons, solely bound by the magnetic field in the ring. For each halving of the mean distance between polarized electrons, the magnetic binding energy grows more than 8-fold, attracting surrounding atoms from the periphery. As a result, these cluster about the forming exotic vacuum object, their electrons binding themselves magnetically into the ring. This proceeds until most atomic and molecular shells are half empty. So if you had elements like, I don't know, mercury and tungsten and xenon that have a lot of shells, then they have a lot of electrons that they can give up. Longitudinally squeezed and magnetically polarized piled disks. Again, this is close to the Mashinsky thinking in the spin nuclear electron condensate. At this point, the critical electronic spacing of 10 to the minus 14 is reached, whereupon the radiation of neutral shrinking Landau states expels their nuclear core and makes them switch to relativistic regime of self-sustaining charged EV, in which the vacuum polarization and mutual magnetization of electrons allows for lower energies as described in the appendix. All this occurs near the cathode, so that the expelled ions are violently accelerated back into it, where their recombination creates an explosion likely to damaging it. This is observed. This is in the book by Lafferty, in this one here that was, if you read this patent right here, like in the introduction paragraph, it talks about the importance of this book, which was, I think, published in 1981, but goes all the way back to 1932, I think, with various pieces of work. And it actually talks about these processes kind of here and in detail. Okay. Hence the preference for liquid metal cathode. So this liquid metal cathode was used by Tesla in his 1930s death ray, and it was used by Ken Shoulders in his patents, and additionally in this patent that I've showed you today. And it's also being considered to coat the inside of tokamaks, the tungsten shielding. They want to coat that with liquid metal. Okay, so X-rays should be produced at that point. In order to avoid contaminating the newly formed EVs with ions, Ken Shoulders places a drift tube that radiatively stimulates this initial shrinking just after the EVs are produced. One consequence of this mechanism is that a negative pulse is immediately drawn upon the formation of each EV into the cathode from the return of the ions. This must be damped by a resistor, hence this resistor that you have here on the input side. There we go. Okay. The ions must preferably be of some heavy element, such as mercury or xenon, like both of the elements that you get in a low pressure automotive HID tube, which have ample supplies of electrons in the D and F shells. The reason why exotic vacuum objects have been thought to be spherical could be related to the traces that they leave upon colliding with anode and exploding at its surface. Most likely, they form into small tori that bind magnetically into larger torus. Really? Well, really? Little tori that then bind magnetically into bigger tori? Don't know where we've seen that before. Just don't know where we've seen that before. Such an electronic loop may exist in two states: ferromagnetic with longitudinally aligned spins, which is how it generally appears in a solid state and when formed in a discharge, or antiferromagnetic with transversely oriented alternate spins. The decay from 1 to 2 involves that of magnetic flux that subtended the initial state. Note the longitudinal binding is twice as strong classically as the transverse. Are we there yet? Yes, Simeon Hain. Fractals, but it is, you know, it's weird to be reading this now. I guess, what is it? If it's late 2016, 17, 18, 19, 20, 21, it's 5 years ago. And there it is, right in there. He's speculating that it forms tori, and the tori magnetically bind. And that's exactly what we saw by studying the impact marks and the self-similar scalar clusters on the Hutchison fracture sample. I lift my glass to you, sir, for having such insight. Okay, that is just Cafola. It's like fake cola. It's just to keep me awake whilst I'm talking to you. By virtue of this attractive potential, such loops could, except for the energy associated with their charge, shrink up to an interelectronic spacing of 10 to the 15 meters, when the magnetic potential, akin to the classical superselection rule, is strong enough to confine the transverse kinetic modes of the electrons into a torus, as happens in very thin conductors, while confining the longitudinal modes is taken care by Pauli exclusion principle. The energy balance comprises the energy of the electron's transverse and longitudinal kinetic modes, which increases as 1 over r squared in the initial low energy regime, and as 1 over r in the relativistic regime, which is predominant below a scale. If we assume the little radius r of the torus to scale with the big radius, the electrostatic energy that increases as 1 over r and r shrinks, so that the overall positive energy, kinetic plus electrostatic, scales as plus alpha over r below a scale. There is also longitudinal and magnetic potential, which grows increasingly negative as minus 1 over r cubed. The overall energy thus scales as alpha over r minus beta over r cubed in the relativistic regime, the latter term always dominating at some point. As a result, a stringy EV that shrinks in vacuum loses energy and would convert the entirety of its initial mass, or more if an external attractive potential well into energy, were it not for charge conservation and its associated energy. In the process, it emits ionizing radiation, causing it to self-accelerate and zigzag wildly from the recoil as a white EV. This shrinking is manifestly limited, otherwise the vanishing mass would allow it to reach relativistic velocities even in modest potentials of 10 kilovolts over sufficiently long paths. Its limit is set by the reduction in the electrostatic and magnetic self-energies from the reduction in magnetic permeability mu0, owing to huge magnetization, and the increase of the permittivity sigma 0 of space under the intense magnetic and electric fields, the latter of which increase the density of electron-positron pairs. So you actually have such high electric fields, and we saw these calculated as being 3.6 tera electron volts, I think it was, from the international paper, that they actually increase the density of electron-positron pairs. Now, is this birthing these out of the 0 point, or is it birthing this out of the matter that it's captured along with the electrons? This allows for somewhat lower mass to charge ratio at the origin of the 2 keV transitions observed by Ken Shoulders. Okay, so he sees many of these 2 keV output photons, which he believes correspond to the binding energy per electron within an EV. 2 killer electron volts. The binding energy per electron. Wow. Okay. In that case, only the inversion of the dynamics can be contemplated as plausible explanation for the puzzling, sudden and reversible apparent vanishing of both mass and charge. So he says, in that case, only the inversion of dynamics can be contemplated as a plausible explanation for the puzzling, sudden and reversible apparent vanishing of both mass and charge. In most of what follows, I shall assume the charge of exotic vacuum objects to remain constant. Okay, so in his assumptions, he's saying it's not losing the charge and mass. While shrinking EVs do not directly convert mass into electrical power, their ionizing radiation can be harnessed to knock off electrons from the cathode or other metallic surfaces at lower potential than the anode. This is key. At lower potential than the anode, around the EV's path, therefore producing an excess of electrical power. This could induce the mysterious drop in potential seen in charged surfaces near EVs. The resulting shrunk state could be a candidate for what Ken Shoulders called black EVs, because they do not radiate. Upon colliding with the anode, these may become excited again into disordered electrons by sucking the anode's thermal energy. Upon colliding with the anode, these may become excited again into disordered electrons by sucking the anode's thermal energy, which could be the cause of the mysterious cold electricity or may catalyze exotic chemical and nuclear reactions. While the extraction of electrical power from exotic electrochemistry or nuclear reactions is exothermic and consumes fuel, that from cold electricity requires closing the loop, recycling the shrunk electrons in the anode, and therefore supplying the anode with a flow of heat. That from cold electricity requires closing the loop, recycling the shrunk electrons in the anode, and therefore supplying the anode with a flow of heat. This endothermic regeneration of free electrons from exotic vacuum objects could be the dominant cause, along with the breaking of the boundary layer by negative ions generally put forth as the explanation of electrostatic cooling. Are we there yet? Hi, David. Yes. Okay. See you later. Thanks for joining us. Right. Ken Shoulders observed that some EVs tend to lose suddenly most of their mass and charge while keeping their ratio unchanged. One explanation is a temporary inversion of their mass and energy along with a gravitational decoherence. A gravitational decoherence from the Machian background at infinite or negative temperatures related to partial or total phase. Negative temperatures? Negative temperatures? Related to a partial or total phase transition. In the framework of an induced gravity, with the result that energy, mass, temporal evolution, and thermodynamics of certain substates inverts, and that their bound states with counterparts of positive energy see their kinematically measured mass and charge almost vanish while generating puzzling kinematic anomalies. We've seen some pretty puzzling kinematic anomalies, haven't we? I think we have. A temporarily inverted EV acquires a positive charge and affects its environment accordingly, but behaves kinematically as though it were negative. So, a black EV, would that go to the cathode? It might do. While the transition to such states is seamless, that of negatively charged EVs to a negative mass, while keeping the charge and the overall temporal evolution unchanged, would involve strange boundary conditions and the emission of electromagnetic or gravitational waves. Would involve strange boundary conditions and the emission of electromagnetic or gravitational waves of positive energy. In order to conserve momentum, while its reverse requires the absorption of such radiation or an emission of gravitational radiation with a negative energy. This may then result in non-conservation of momentum on the scale of experimental device, although it can be shown that its global dynamics will conserve momentum and energy. So, the implications here is, for it to be losing its charge and mass, there should be effectively gravitational waves of positive energy output, and the overall the effect would be to have no overall breaking of the conservation of momentum and energy. Okay, so I read this paper very roughly, I guess, back in late 2006, and this primed me for recognizing things in Lion and for recognizing things in other systems and recognizing them in this video in Vega. When I saw it, I was already seeing the wood in the trees. What you're seeing here is not only can exotic vacuum objects potentially provide a clutch between almost like a heat pump, it might be something that you can use as a gravity pump. And in fact, Ken Shoulders says that you can rectify the mass in this, and in fact you can create a propulsion system where you shift it one way in the black state and you then make it white state and you shift it back that way, and then you put it into the black state and you shift it back that way, and this effectively in both directions. What you're doing is you don't completely lose its charge, but you're lowering its mass, and so you shift it backwards and forwards, and he calls this propulsion by rectification of mass. And so it's a really novel way to do propulsion. Okay. So along a similar line of reasoning, given that the behavior of the quantum objects results from their random walk in space-time, whose temporally reversed paths involve inverted energies, masses and charges adding up to a conjugate wave function, and that the dynamics of self-sustaining exotic vacuum objects implies that they are macroscopic coherent quantum states. The dynamics of self-sustaining exotic vacuum objects implies that they are macroscopic, coherent quantum states. And I don't even know whether I read that in 2016. Maybe I did. Maybe I had that in the back of my mind when I'm seeing all these things in Vega and in other experiments. Anyway, macroscopic, coherent quantum states. It then follows that they should exhibit the quantum behavior expected of the wave function of an indivisible quantum object. There you go. There you go. Right there. You're not looking at it. Sorry, I'm so excited that this is here. Look, masses and charge adding up to a conjugate wave function, and the dynamics of the self-sustaining exotic vacuum objects implies that they are macroscopic coherent quantum states. It then follows that they should exhibit the quantum behavior expected of a wave function of an indivisible quantum object, such as an atom or molecule. That is what we saw in Evo Chop Shop. When you had the balls of fire, they resonantly arranged themselves opposite on the tungsten wire. And then they were energized and pumped and pumped and pumped until it chopped off a section of that tungsten wire. And as it fell, That ball, which was attached to that wire, then shifted itself along with the wire, and the orient, like it was a gimbal. It was like a hinge, but like a ball and socket. But it shifted its magnetic pole to point at the other ball as it fell down. And that for me was telling me that whole structure was acting as one quantum object right there. And I think other researchers that have dealt with ball lightning have observed this same phenomenon. There he has it. He says it basically, for the things that Ken Shoulders claims it can do, it had to behave as a single quantum object, and I believe it is. This is a quantum coherent structure. Okay. Which may split into several branches upon being partially reflected or scattered. Well, yes, it does. We observe that. Might then its mass and charge become diluted along its wave function so long as it interacts minimally with its surroundings? As for quiet EVs, I think probably it would. Upon interacting, the wave function would collapse. There we go. Upon interacting, the wave function would collapse, and it would then instantaneously localize its mass and charge. This is this other mode of propulsion that Ken Shoulders proposes, where you make the EV, you lower its charge, but you still have some charge so you can accelerate it, and then you move it along, and then it interacts with a metal or an anode, for instance, and then it instantaneously becomes regains its mass, and then you have the impulse of all of those ions and electrons traveling with the velocity you imparted to it, but you didn't need to use the energy to shift it there. And so these two different methods are methods of propulsion that rectify mass without actually losing the mass. You're not having to spit it out of the back of your thing that you're trying to move forward. Might then the mysterious black EVs be partially scattered wave functions of quiet EVs, the tickling of which would make them interact, whereupon they decohere in the quantum mechanical sense and localize. To conserve energy and momentum locally, the vanishing branches of the wave function would then emit gravitational waves with positive energy and momentum, while the newly localized EV radiates gravitational waves with negative energy and momentum, which exist in certain theories of gravity. According to a more plausible view, however, there is no collapse of the wave function, which only reflects our incomplete knowledge of reality. In this case, the entire wave function arises from the temporal whereabouts of a single entity. Only its positive mass, energy, and usual charge interacts with some element of its environment at a positive temperature, and when this occurs, the whereabouts of the wave function cease, and its unused branches, which exactly combine world lines of opposing momentum, electric current, mass, and charge into pairs, amount to nothing. Therefore, the shadow EVs cannot be explained in this way. So, right, nuclear reactions can be induced by exotic vacuum objects carrying and accelerating nuclei to relativistic velocities in vacuum, by their screening the Coulomb potential between fusing nuclei, and, most interestingly, by their modifying the alpha tunneling probability. Alpha conjugate nuclei? Alpha conjugate nuclei? Anyway. By their modifying the alpha tunneling probability of heavy elements, and thereby hastening their natural alpha decay. Oh, have we seen some tungsten with an alpha decay mode? I think we did at the beginning of this presentation. When it's environmentally friendly, as no radioactive waste is produced. While these processes may release energy in a short span of time when the EV collides with an anode and decays. If we've got an anode in our HID bulb, which is made of tungsten, which they are, then maybe we can get some thermal energy from this, which would help to reconstitute those electrons that lost the thermal energy when they were cohering. Short span of time when the EV collides with the anode and decays. The second and third may also occur continuously below the surface of the current carrying element. And this is below the surface of a current carrying element. That's essentially what we observed in Lion, and that's essentially what Matsumoto has observed. The current would preferably be in the form of short, unidirectional pulses at such frequencies as to maximize the formation of coherent ferromagnetic loops below the current conductor's surface while avoiding its explosion. Yeah, we don't want to explode the wire. Fusion may occur in the solid state, in deuterium-loaded palladium, in other systems, while alpha fission may be contemplated with heavy elements such as tungsten, uranium, or thorium. A reactor would typically consist of a wire at the center of a conducting pipe. The induced fission would occur inside the wire, heating it so that the power is extracted by hot electron emission. So he's making some speculations here. Okay. A possibility that does not involve nuclear reactions is to consider the exotic chemical reactions such coherent electronic states may induce in various materials, such as those in low-pressure gas cells. Ordinary batteries... Oh, really? What, you mean like some batteries that you might get in a Tesla vehicle? Conductors or magnetic materials subjected to certain unidirectional pulses. These will be transformed into atomic isomers with higher binding energy, as found in the Rayleigh process. Before making claims of free energy, the detailed examination and analysis of the materials involved in the devices should be performed so as to detect any structural change, whether of a molecular, atomic, or nuclear nature. Yes, we know. Yeah, and we've done a lot of that. Thank you. In the second law of thermodynamics about to lose its is the second law of thermodynamics about to lose its standing of 1 century and a half, seeing as several open quantum systems are now known that explicitly violate it. These are unidirectional open systems in which the reverse transition channels are closed owing to destructive quantum interference. This allows such phenomena as rectified Brownian motion, anti-Stokes lasing, without an externally induced population inversion. The phenomenon of cold electricity, which we're talking about here, manifestly belongs to this category. Because such processes involve negative temperatures. So you really can have something that gets really, really cold really quickly. They must correspond to negative energies, masses, and reverse temporal evolution. According to E.C. G. Stueckelberg, which enforces the second law of thermodynamics at the cost of expected temporal ordering in such states. Below are some processes of this kind in exotic vacuum objects. Okay, I love this thing. This is one of Ken Shoulder's devices. So, one of Ken Shoulder's devices. Exotic vacuum objects are produced from the tip of a wet metallic cathode. This is our wet metallic cathode. So this is our tungsten tip, and it's wet with mercury, and sometimes it has a guide. There's our negative pulse. These are our negative pulses coming in. And here are our toroids going through here. And they're going from the white state shortly after leaving the cathode from the pulse, and they're going through to the black state. Okay? EVs are produced from the tip of a wet metallic cathode at volts is 4 kilovolts. Connected through a 500 ohm resistor so as to stabilize their formation. So that's the back shock from the ions coming back. So Shishkin describes this well, and I'm going to be translating some papers of Shishkin. He's given me permission to translate them and publish them, and I'm going to do audio recordings of those as well. And so he says that these solitons are atoms that have lost their nucleus, and that's also in his presentation from 2018. Anyway, so there's these solitons coming out, and as they radiate 2 kiloelectron volt photons, they appear as white EVs. They pass through a metallic tube at an intermediate voltage. So this is the negative voltage divided by 2. So this is more negative than this, and this is more negative than the anode, okay, as he was describing earlier, where their ionizing radiation induces electrons to be knocked off from the photoelectric effect. Where their ionizing radiation induces electrons to be knocked off from their photoelectric effect. So as it is radiating here, 2 kiloelectron volt photons. Okay, so these are soft EVs, because these are soft X-rays. So I think it's up to 5 kiloelectron volts is our soft X-rays. So these are soft X-rays, and they're being emitted, and I assume that there will be the EUV there as well. Those are coming out, and they are hitting this negative half bias relative to this potential tube in this tube, and these are emitting electrons from this tube. Now, I would coat this tube with a copper oxide of some types, and that's why we were putting copper tubes into our Vega experiments. Or I would use yttrium oxide coating. Why? Because yttrium oxide has a work function of 2, approximately. And that is very close to the 1.8 or 1.9 of cesium, which has the lowest work function. But cesium is terrible to work with, just wouldn't work. But yttrium oxide has very, very high temperature operating. So we're not talking about getting an electron for whatever it is, 12 EV from xenon. We're talking about an electron for a 2 EV, so you get 6 for 1. And we like that. We like 6 electrons instead of 1 for the same ionizing energy. Okay, so yeah, so we have a lot of electrons coming here. As they radiate 2 keV photons, they appear as white EVs, pass through the metallic tube at an intermediate voltage, V over 2, and that's negative V over 2, where their ionizing radiation induces electrons to be knocked off from the photoelectric effect. It also accelerates the EV's shrinking through stimulated emission in this cavity, where the other EVs are radiating their energy away. So you got like electrons coming out, this stimulates it, you get more emission, and you get all the electrons coming off as well. This is the source of the electrical power that is produced. So essentially, you have these extra electrons that are coming out from the mass to photon conversion as the EVO is shrinking and going from the white to the black state. When they exit the tube, they have radiated off most of their binding mass energy and have become black EVs. While the drawing illustrates single EVs, it seems that EVs may be formed into toroidal clusters. The reasons could be that the presence of short pulses in an axial magnetic field, the current feeding the cathode has an initial axial vorticity. As the pulse reaches the tip, the angular velocity increases, and the toroidal plasmoid carrying a small vortical loop of current is formed that also has toroidal vorticity, as in a smoke ring. Owing to the mechanism of its formation, the magnetic field at the tip then decays, subjecting the newly formed toroidal vortex to a poloidal induction, forming on its equidistant shrinking EVs. The same mechanism of EV's formation by the decay of a loop plasmoid currents may proceed in electrodeless discharges. Their radiation, their radiation then dissipates the plasma, and only the EVs remain in the shape of a skeleton of a torus held together by magnetic and Casimir forces, which is possible if each EV is a rigid superconducting loop. This leaves bead-like traces upon their decay on the anode, and we have observed this in our experiments, and obviously Ken Shoulders did and others. I once remember EVs being put forth for exciting phosphors in flat CRTs. One problem was their variability. Interestingly, IBM recently announced that their new flat CRT, this is a long time ago, had its cathode tips embedded in a sheet magnet, which probably solved the problem. as the exact dynamics of the pulse becomes less critical in a strong field. This is something we should bear in mind. The exact dynamics of the pulse becomes less critical in a strong field. Okay? In this case, the plasma involves a noble gas rather than a wet cathode. EVs may also penetrate the anode transversely and decay, leaving two holes. EVs may also penetrate the anode transversely and decay, leaving two holes, as seen in some of Ken Shoulder's photographs. Once in the anode, these aggregates use thermal energy, the thermal energy of the conduction electrons, to be restored back into free electrons, so that the electrical circuit can be closed if the heat is supplied from the outside to that effect. This would clearly be an endothermic process, which I now realize should not violate the second law of thermodynamics. Its efficiency is improved by feeding the heat generated in the midsection to the anode. So in the midsection here, you could improve that process, it's saying. Okay. Note the similarity with EV Gray's and the Henry Murray's tubes. Other configurations can form such entities in solid state and induce exothermic, electrochemical or nuclear exotic reactions. Since the EVs may emit electrons and antineutrinos, as they shrink to the photoelectric showers that are shown, could be added those from the EVs themselves. So, since the EVs may emit electrons and antineutrinos as they shrink to the photoelectric showers that are shown, could be added these from the EVs themselves. So you could have a whole bunch of antineutrinos moving along here, a whole bunch of electrons coming from the EVs as well, and electrons coming out from the photoelectric effect. And then when it gets over to the anode, you have this cooling process, and you also have, as the thing disrupts, you have exotic nuclear reactions that can occur. An intriguing question is whether a similar process could occur within the confines of a semiconductor. Several experimenters report unusually strong back EMF from switched coils with ferromagnetic core polarized by a permanent magnet. Examples of such devices are Bearden's MEG and Floyd Sweet's device. I am thankful to William Alec for sharing with me the results of his experiments with a motionless shock charger, which uses the back EMF to charge a battery. He notices that a permanent magnet substantially increases the efficiency of his device. I shall assume that the current organizes itself as progressing vortical magnetic rings surrounding the wire just below its surface. These are similar to in nature to EVs in a vacuum or rarefied medium, though of a lower density and electrostatic energy. Okay, are you bored yet? Right. The current flows against the magnetic field and prevents the ferrite core from being magnetized. We may assume the total magnetic field to be small at the center, the advancing vortical magnetic rings of the lander, blah, 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 blah. So this is talking about various other technology that could be related to this thing. The shrunk vortices now have highly negative binding energy, while the interaction with their medium increases their disorder, blah, blah, blah. In the case of apparent over-unity, the noticeable temperature drops in the coil would be part of the thermal cycle having an external heat flow, while exotic chemical nuclear effects are exothermic. So yeah, what I was saying in the Lion is that when the EVs were disrupted, who were basically sitting being superconducting in the Cu2O quite happily, when they were disrupted, they kind of disheveled, and at that point they produced a pulse of heat and then an intense cooling. Okay, so the main problem I see is that since everything happens within the confines of a wire, a higher proportion of the radiation from the shrinking electronic tori may be turned into heat than in the shoulder's grey tube. thereby shortening the thermodynamic cycle. William Alec seems to support this view, noticing that thinner wires dissipate heat and lower the efficiency of his devices substantially in comparison with heavier gauged wires. Also, some of these shrunk states may end up altering the copper in the long run, but the same problem would potentially affect any other such devices. To conclude, while a perpetuum mobile of the second kind is improbable, the existence of exotic forms of matter involving bound electrons represents a new source of atomic and nuclear energy that has already been tapped by several researchers in reproducible way since Lord Raleigh's pioneering experiments. It is well documented and expected to lead to industrial applications likely to answer our needs for reliable, new and clean sources of energy. Okay, so after that marathon reading, I don't know whether I want to read the other paper, but I think we need to, because I haven't read it yet, and I think I'd like to read it with you and just see what it has to say. Anyway, there's a bunch of references down here, and we've got Centillion here, we've got Shoulders, we've got Beirut, fantastic, Gin as well. Randall Mills, Lord Raleigh here. So you've got the links to the papers here from Lord Raleigh. Yeah, and some great references there. And then he goes into the different ways of calculating how this can come about, the bound states between the electrons, and so on. For those that are interested in the nitty gritty here. It's in the latter part of this paper, and he talks about how you have these time inversion, so on, and this. When I was reading this, it says two EVs interacting, one of which flips twice its temporal orientation from an induced uncoupling from the Machian background, becoming a black EV in between with a reversed momentum, mass, and charge. And thermodynamics that dynamically sustain its retrochronicity from a shrinking negative mass as viewed in our time by its absorbing ambient photons. Therefore, the electric and momentum energy currents are strictly conserved. This kind of looks like those squiggles we see in our coherent matter travelling waves. So maybe this is kind of what's going on. I don't know. I'd like people to maybe dig into that and have some opinions on it. That would be interesting. Okay. We are all polyvalent here. I see. Yes, very nice. And this is maybe one discussion on propulsion here and so forth. But okay. So I recommend people delve into that, read through it again in their own time. But as I said, this was context for me. At the end of 2016, I believe, into 2017, I had in the back of my head. I hadn't read it all the way through because most of it at the time looked like gobbledygook, and I hadn't seen physically anything myself that supported any of the observations made by Shoulders or the claims made herein, so it was only. Later, having seen what happened in Lion and found other systems reporting this, and then seen what happened in our Henck's Vega experiment, that I really accepted the observations of Ken Shoulders and others in this field, all the way back to Murray and Sweet and Menellis and so forth. But anyway. So I'm going to have a look before I go on to the next document. It is a shorter document, I think, from memory. And I will see if you've got anything you want me to answer here quick at this junction. Okay. I think WP for Truth, there's an email for this guy in the document, which I've given you the link to. He's the mathematician I think you should work on because he really knows his maths. I think it's sawtooth waves, but extremely tight on the initial DIDT. what has Bearden ever produced in his post-retirement from Army life? I don't know, Bob. I don't know whether he's produced anything. I've got other than collections of his presentations like this one. But this was another waypoint for me, because after I started saying, I think it was it in? It might have been in 2000s. Yeah, it was in 2017. I was saying that I expected things to be becoming cooler. It might have been in 2017, maybe I think it was 2018. I don't know. Anyway, I can't remember. I was led to read this, and in here it talks about the large amount of electricity carrying down a very fine wire, and also the softening of metal. So where is that? Anyway, I've read it to you before. So it helped me, and I saw it in that book before I saw the news report, and then so sometimes doing something is better than achieving everything. You just have to make steps, and everyone can play a role in taking the science forward. That's what I believe. Okay, so stand outside in a thunderstorm, best way to realize the user. I couldn't agree more. And Beck, I often find myself knowing when I'm going to get struck by lightning. I predicted it twice on my house in the UK. I get a very intense, weird feeling in my head. I'm very electrostatic sensitive. And so, yeah, you can definitely feel something going on. Certainly the electric field. Yeah, the Michelson-Morley, that 6-hour experiment that changed a lot. But I think we can move on from that. I think we can utilize what they said didn't exist, and the people can still claim it doesn't exist. It doesn't really matter. We'll get on with using it. We're all polyvalent here. I love that one. That's good. Just don't. We're not bored, Bob. Just don't read the chat. Very good. Okay. Yeah, Axel is maybe right. I don't know. He's saying vacuum fields are created by the Higgs field. Without the Higgs field, there would be no space-time. It's all very interesting, but I kind of like what I can see. I can see that you're putting power in, that we're making plasmoid structures on this, and that we're seeing poppity pop 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 on the background, and that it's cooling the environment. You're getting these spherical flashes, and you're getting a coincident EMP, and that those things collectively together support the claims. And it's in video. It does what it says in the claims, but on a scale which I can absorb. So there's obviously something going on that's deeper than what I've discussed in this paper by Karopoulos. But I want to use it. And so people at some other point can argue and decide what's going on at the minutiae level. That's not where I'm. For me, I'd like to see what I'm looking at, essentially. Okay, I'm going to go, and I'm about 1/3 up. This is going to take a while. Okay, I'm going to read this other paper because it shows the seriousness of this researcher in this field. Okay. In fact, before I do that, I'm going to tell you that I will be launching the the Kickstarter, I hope on Tuesday. I've gone through all the banking and so forth, and that's all passed and everything. And the Kickstarter are happy with those legal aspects. I've agreed with Henk on what we're going to do. So I would like to get a motorized macro rail out of it, and maybe something to work with. Henk wants some xenon and some valves, and those two things are about the same sort of price. I think it's between one's about 750 euros and the other one's about 900 euros, and something to work with. So those are the things that we want to try and get out of it, over and above my effort putting the things together. But if I can pull it up, I'll tell you what I am calling it. Maybe I can pull it up over here. And if people have got another idea for the name of the book and so forth, then I'm happy to hear what you have to say on that. So let me just pull that up. Okay, so at the moment, the name, it's going to be 2 books, and it's kind of like a trial run for the Hutchison book set. So the main reward will be, for pledges, will be a beautiful landscape book showing high-resolution macro photography and electron microscopy images of the Vega Valley. And the book will be called Vega Valley, the home plasma balls built for themselves. I wanted to say coherent matter. I wanted to say exotic vacuum objects. But I want something that is 100% identifiable as the truth, regardless of your opinion of what they are. And so I'm calling it Vega Valley, the home plasma balls built for themselves. And the subtext will be a stunning visual testament to the innate self-organizing creativity of nature. And so in there, it will be a glossy hardcover, 11 inches by 8.5 inches with 20 pages. And the companion book, so in the photo book will just be what nature created. That's it. There's going to be no analysis, no opinion, no judgment. Just the physical microscopy, macro, photographic, scanning electron microscopy data. Those what nature did and how it presented itself. And then the sister book will be a PDF. Initially, at least, for the Kickstarters, and there will be potentially updates for that over the year. But it will be a book, and the digital companion book will contain schematics and photos of the setup that created the Vega Valley. This will be the first time that those will be shared. Details on operation regime used to produce the effect. Elemental analysis and discussion, including hypothesis for what is occurring. And so this means that the PDF book I can update a number of times as there's an iteration in understanding and as more things are discovered. But the photo book will stand the test of time because it is just what nature did. There's no projection onto it of hypothesis from any party. And therefore, the book itself could be used in the future for other people to understand what nature did itself. And I'm trying to be faithful to Piantelli's advice in January 2015, where he said, don't tell nature what it is, let it show you. So that book will be showing you. The other book will be analysis, and then that will be still looking at it, what it was trying to show us, and then there may be some hypothesis in there based on best understanding for consideration. And so that is the plan for the Kickstarter, which I hope to launch on Tuesday for the Vega Valley book. Okay. Right. So I'm going to go and do this second piece of work by C.P. Kouropoulos. And it's called self-magnetized electronic filaments. Maybe I'll get that bit bigger for you. Can I get that bit bigger for you? It's going to get a bit big. Okay. So the abstract here. In the one-dimensional world of a flux line beyond BCE is 4.41 gigateslas. Paired evanescent low-momentum zero-Landau electron states condense into magnetized bosons of vanishing momentum. I used the results of Rojas et al. Within a potential and show that magnetic intensities and electron densities sufficient to initiate condensation are achieved in the shock waves of cathode hotspots. Cathode hotspots are what you see here in this work of Lafferty and the co-authors in here. This is cathode hotspots, my friends. There we go, in this book, page 143 of Lafferty et al. From unipolar pulses on the surface of discontinuous microconductor or cathode tip, as discharge suddenly self-interrupts. Above BCE, there are charged electronic vector states that are superconducting and ferromagnetic. Assuming the magnetization of the vacuum within the flux quantized state to be free, thanks to Euler-Heisenberg renormalization, extends the range of allowed stable states. The thinnest filaments have the Compton radius for the effective boson mass. When perturbed, they evolve towards a decaying state with negative mass and vanishing density at BC, or further condense into composites of higher mass, charge, and critical field. Open, almost neutral filament systems with one flux quantum and longer than 4 microns would be metastable in Earth's magnetic field and terminated by magnetic monopoles. Hey! All right. Good so far. Right, good. Introduction. Although the effects of magnetized electronic condensates have been observed for decades in the form of charge clusters, monopole pairs, and sources of low energy nuclear reactions. There we go. Look at this. In the mid-2000s. From charge clusters, monopole pairs, and sources of low energy nuclear reactions, they are neglected aspect of condensed matter physics, mostly because they imply extreme conditions of magnetization and charge density that were expected to be relevant only to astrophysicists or astrophysics. In fact, these may commonly occur in various arc and spark phenomenon. The resulting condensates may turn out to be conducive to efficient microfusion and nuclear transformations. The energy stored in them partly originates from the forced charge separation that occurs after their formation. With this charge separation, we saw, you can't see it, can you? Hi, bye Henk, I'll see you. This charge separation you see in that experimental synthetic simulated soliton in that paper that I recently showed by the international collaboration. The charge separation of negative 1.8 trillion volts per meter and positive 1.8 trillion volts per meter. Okay. The resulting condensates turn out to be conducive to efficient microfusion nuclear transformations. The energy stored in them partly originates from the forced charge separation that occurs after their formation, when part of the screening condensate of confined nuclei is dispersed against the binding Coulombic potential by its nuclear reactions. First, the results of Rojas et al. Will be reviewed, then applied to descriptions and dynamics of such condensed electronic states. A consequence of the anomalous magnetic moment is the possible existence of states with a negative mechanical mass. These would represent only a tiny portion in the spectrum of such states, but would have observable consequences for the overall dynamics, as well as the distinct radiative signature in the form of pairs of E is less than or equal to gamma AM approximately 1.18 kiloelectron volt photons. Okay, interesting. Magnetic bosons. A vanishing momentum electron gas becomes one-dimensional and can be bosonized with the magnetic binding of the zero Landau state when the magnetic binding of the zero Landau state exceeds that of ground Coulomb state, n equals 1, with this blah-de-blah, i.e. the field is, what? 235,000 Z squared, is that Tesla? I don't know, okay. With Z of the heaviest nuclei in the system, Z is square root of 2 for virtual positronium and in vacuum. Okay, all right. In a one-dimensional world of magnetic flux line beyond the critical field, BCE is 4.41 gigatesla. Such electrons acquire a complex energy and bosonize spontaneously. Evanescent electron pairs condense into charged vector bosons, whose charge, spin, mass, and magnetic moment are assumed to be the sum of their constituents. This fails to occur in higher energy scattering because of the p-squared term under the square root and simultaneous decrease of the ordinary magnetic moment with increasing momentum. Okay, all right. The dynamics of condensation. The charge vector bosons in the n equals 0, 1, 2 Landau orbits about the z-axis magnetic field have energy eigen value is that, and with these parameters. Okay. In addition to the electrostatic energy, U where's U? U there, plus U, may include the magnetic energy per pair. While the mass per boson for the overall condensate is sigma n plus or minus divided by c squared, the boson effective mass with the condensate and transverse kinetic term relative to the magnetic field is that. Okay. For simplicity, it was blah, blah, blah. Okay. All right. Well, he's working this out, and I'm not going to go into it because I am reading it right through now, so I really don't know what's going on. Okay. Above B is 8.81 gigatesla. Both M0 and the Hamiltonian become complex and state decays. Whoa. Okay. All right. This might not be easy reading. I swore I'd never give you any equations, so I'm sorry for this. Okay, blah 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 blah. What are the implications, my friend? Okay, blah 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 blah. Charge states in the potential. The solution for the condensate is mu minus u on the left-hand side of 13. This one, with u vanishing out or moderately confining, as in blah blah blah. The condensate is most stable at blah blah blah. Both bands blah 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 blah. We're not going to get much from that, right? Negative mass states. This is how you get them. The energy of the vacuum. This is dealing with the vacuum. The vacuum pressure. Blah 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 blah. The square blah blah blah. I don't know whether we're going to get much from this. It's a little less accessible than the previous one. The magnetization is all that. Oh, this is lovely. I'm going to give you the presentation, the slides, whilst I remember. So you can view this in your own time. I know that you're all very, very eager to read this paper, I'm sure. There are things that we will get out of this, though. So, paste. Okay. Okay, right. So, yes, it would appear that negative mass is important, Axel. Okay, so, although, as I say, the observables and how we can work with them is, we need to achieve the observables, like certain intensities of photon output and certain intensities of change of temperature. Okay, so blah, blah, blah. This represents a path to self-condensation. Note the steepness of the magnetization close to this. Okay. La 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 la. An interpretation of this solution and of the following curve is that as the effective mass and equivalent spin current of the bosons decrease, are divided by the Simon factor, whatever that is, they're intrinsic. It helps to be Greek when you're using Greek letters in equations, I tell you that. their intrinsic period, magnetic moment, Compton radius, all blow up, are multiplied by the same factor, blah, so that they occupy a larger and larger transverse surface, while their longitudinal packing increases somewhat as their magnetization becomes that, which decreases the density as that. Classically, this is akin to the tendency of the coils in a solenoid carrying a high current to stick together, while they expand radially into a thinner and thinner equatorial ring. How to reconcile this blow-up with the negative pressure? One answer is that the larger volume of space is magnetized. A larger volume of classical magnetic energy, b squared over 8 pi c, is absorbed by the quantum regularization of the vacuum energy. So this expansion is accompanied by negative work. Therefore, there is also missing electron mass there from the magnetization in the vicinity of 8.82 gigateslas. The effective mechanical mass becomes negative and equal to Okay. It's not good. I should have read this one before, probably, and then I might have been able to give you something once I understood it a bit more. During the radio expansion, Okay, so what are we getting to? A torus with n electron pairs. From the bulk density of the condensate is that. Its lineal and surface counterparts are these. The filament, a closed flux ring of large radius r with n dash bosons, is locally approximated by a long solenoid where that and that. The current I in each coil boson, assuming the effective Compton radius for that, is this. The maximum volume density of the condensate pairs is this. 6.44 times 10 to the 14 m to the minus 1. The maximum electrostatic potential per pair is this. The filaments lose magnetic visibility to their larger surroundings when the Dirac condition. Okay, I have to take your word for it. Okay. The candidate filament with the lowest field has a equals 14 mega electron volts. 14 mega electron volts. 14 mega electron volts. Ooh, could that be a higher binding energy than any other nucleon? What is the binding energy per nucleon of helium? Binding energy of helium. Yeah, nuclear binding energy, please. Per nuclear binding energy of helium-4. I can't remember it being something like. Can someone find me the nuclear binding energy or per nucleon of helium-4? I think it's something like 7.1 MeV. There we go, guys. 7.1 MeV, right? I think we need to have nickel 62. Nickel 62. Nickel, I think that's 11. Is it 62? 8 point, well, okay, there we go. It's not 11. So what we are seeing right here, my friends, the candidate filament with the lowest field is a total energy well above. Okay, all right. Well, I don't know whether there's any nucleons in there, but it's a lot of binding energy. That is a lot of binding energy. Okay, all right. 14 MeV. The match is between two Compton radii for m over square root of 2 and the two quanta of flux, which describes ferro or antiferromagnetic dual chain. The states with non-integer flux are therefore substantial energy or awkward geometries with non-integer or higher multiple Compton radii. Okay, all right. Okay, and this is how he's getting the 1.18 photon pairs. Okay, so that's okay. All right, photon pairs, that is 1.18 electron volt photon pairs. Charged states with the largest Compton radius and lowest positive effect are stabilized by a positive Coulomb cloud of similar radius. Okay, all right. This looks more accessible. I think we're on some accessible area here. Okay, hopefully. How are such filaments formed? They result from runaway magnetization to BCE that initiates at the density of matter from zero Landau electronic states in a closed flux ring-like microscopic electronic shockwave. A magnetization sufficient to initiate condensation can be reached from very short unipolar pulses traveling down a wire. And this very short unipolar pulses is exactly what Brillouin use. They use very short unipolar pulses traveling down a wire or transmission line, ideally nonlinear and pulse shortening. When the current spike already squeezed into the surface by the skin effect, so you would need a very thin skin, preferentially. I mean, you could have it would be in the skin of a conductor anyway, but you could have a thin skin and promote the effect. In the trailing edge of the pulse's voltage, owing to the self-inductance, reaches a discontinuity such as the tip of a truncated conical cathode, like as in Ken shoulders, often a small asperity on its end surface. As the current pulse concentrates within the micro tip, and in Ken shoulders he used mercury because it produces a Taylor cone, so you always get a micro tip from it. And as suddenly reflected when the matter is pinched and explodes, and that is a Coulombic explosion, the magnetic field grows locally and a magnetized electronic shockwave results. A similar phenomenon occurs in a cathode hotspots during sputtering, even under modest DC feed current. An arc first establishes itself between the microasperity closest to the anode. So he's discussing ectons, which are EVOs, but Georgia Messias really nailed this. But it's in this book. It's in this book. So the Lafferty book, and the latter focusing within it all the current. It then melts the microasperity and its surroundings. Under a steady magnetic pinch combined with electrical attraction of the charge gathering at the tip, a conducting column of molten metal is extruded from the surrounding molten pool, leaving a crater. This is exactly as described by Messias. As the column rises longer and thinner, down to a diameter of 1 micron, and as long as 100 microns, the current density within it reaches 10 to the 12. Okay, what he's writing here, I swear, is straight words for word from Messias. I'm not saying he copied it, but it looks, from my memory, pretty much word for word how Messias describes it in his, I think, 1996 paper. At that point, the sausage instability. So the I love this word, sausage instability. This was in the Paul Collock 1973 patent and referred to again in the December the Paul Collock 1973 patent and referred to again in the 1993 J.R. Roth paper in fusion technology. The sausage instability breaks the liquid micro wire whose tips at the gap explode from vaporization. Owing to the latter, as well as to the magnetization, conductivity falls, while the growing induced curled magnetic field transverse to the current ensures the latter is interrupted. As a result, a large current pulse is suddenly reflected within each piece of the suddenly pinched broken conductor, so that the induced magnetic field grows even more sharply. Whereas in a bounced conductor at equilibrium, such as a cube of copper, the conduction band electrons are continuously reflected off the boundaries. Their density is that of a motionless delocalized standing waves, so that no charge density pulse is dynamically reflected off the walls and no motional electrical field ensues. Here, however, a huge motional electrical field E minus dTA appears that shows the internally reflected electrons and rushes the remainder trailing edge electrons against the magnetized perimeter of the cathode's accidental microtip, and it also attracts a delayed cloud of positive ions to the cathode in its axis. Okay, so whilst I'm not saying it was completely copied with a word called P, this particular description here from the 1996, I think it was, paper of Messias, All of this is good thinking. It's good thinking. I can't really go into it because I'm reading it for the first time right now, but it's good thinking. In a cathode hotspot, the electric current is typically 10 to the 12 amps per meter squared, which implies at an equilibrium magnetic field of a few Tesla at most. And that is blah and blah-de-blah. A magnetic field also results from the time variation, the dielectric displacement, both from sudden increase and decrease of the motional electrical field. Blah, 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 blah. Okay, all right. Okay, down here. No. We're about halfway through. Anyone fallen asleep yet? Chicken or beef sausages? I do hope it's. I don't know. I'm sorry, but I do like pork sausages because I'm English. Sage and onion and I don't know, all kinds of lovely sausage flavours. As the condensate forms surrounding ions screen it while bringing in additional electrons into the zero Landau state. Such screening is most efficient from boson nuclei. There we go! Such screening is most... Oh dear. So it likes to eat bosons. So this is my observables, and this is someone who's approaching this from the mathematical and electrodynamics point of view, and he's saying that the screening is most efficient from bosonic nuclei, like 12 carbon, like oxygen 16, like calcium 40, and so forth, whose pressure is lower and reactivity moderate. At that point, the densely packed screened nuclei collectively undergo fusion reactions and exchange reactions. So fusion is your 2-1 in your Parkhomov MFMP reaction tables, programmed by Philip Power. Thank you very much, Philip. And the exchange interactions are the 2-2 reactions, as well as beta transmutations. Oh, there we go, beta transmutations. This is involving either a neutrino on the left or or a neutrino on the right, which cancels out the antineutrino that's emitted when a neutron emits a proton and an antineutrino. Okay, so those are in the Parkhomov tables, as shown by Filipov and Oretskev. There we go, we got Oretskev. Well done, Oretskev, you made it in here. Okay, owing to the production of odd or different nuclei, as well as excess momentum, the nuclear condensate may explode. I would be unsurprised if it did, with all of these fusion, exchange, and beta transmutations going on, scattering its products and most of the ions. Such nuclear reactions drive the charge separation and leave more negatively charged vector ring unstable if U is greater than 0, or in the presence of an axial magnetic field, a coil that soon unwinds. Ooh, a coil that soon unwinds. Now, I think, you know what I think we're going to see here? I think we're going to see a discussion on strange radiation, because you've got coherent matter that's in a structure, there's a coil, and it's unwinding. Okay, I think we're going to see a discussion of strange radiation here. One effect of this early nuclear screening is to stabilize the initial electronic state. Okay, all right, fine. This event creates metastable superconducting filaments inside the discharge region with quantum size little radii and therefore higher local current densities than are allowed in the ordinary solid state comprised of atoms. The next round of micro discharges and cathode hotspots thus involves such electronic filaments, and their breaking or exploding above the superconducting critical field. If this is going to go and talk about strange radiation, like it's got a Rootskeff there, so I'm hinting that it's going in that direction, then this might explain why we see these coherent matter traveling waves in Vega experiments. The next round of micro discharges and cathode hotspots thus involve such electronic filaments and their breaking or exploding above the superconducting critical field. The induced magnetic fields from such femto electrodes are... Femto is a very small time, by the way. It's very, very small time. Are high enough to condense higher order or even quark composite bosons. Ooh, I like it. Me like it. Okay. A micronuclear reactor. One condition for nuclear fusion is the transverse confinement of the nuclei. It is met within neutral or screened filaments in the zero Landau state of all spinning nuclei, while n equals 1 filaments confine the first Landau state of helium nuclei and heavier, because the cyclotron radius of, that is smaller than the Compton radius, that of the bosons. Ah, it's squishing it into a small box. Ring and a spot. Ring, I think, in this case. For Z equals 2, a nuclei and N equals 1 quantum flux of this, filament endings or shrunk states confine the nuclei beneath or near their surface electrostatically. Below the surface. Filament endings or shrunk states confine the nuclei beneath or near the surface electrostatically. Another condition for fusion is allowed for by screening in the newly formed charged states is a sufficient nuclear density. Packing it into a small box. Charged states also induce the fission of heavy nuclei. Of course, yes. Well, we've seen enough of that. Especially in the singular electrical fields and of their endings, or Zeta-Bewegung fluctuations. There we go. Oh, he's got it all. As well as fast beta transmutations, owing to the density of polarized electrons. Polarized electrons, we've definitely got those. And the availability of low-lying final electronic states for the stripped nuclei. Okay, stripped nuclei. So Aretskev talked about stripped nuclei. And so when you strip some forever stable nuclei, like thallium-205, it will just decay and produce a proton and goes to lead-205. And so he talked about this in 20, but it's not his work. Other people have observed this. It's been proven. I think at least 4 isotopes or 3 isotopes. He gave an example in 2008. So I think there's discussions in this with Oretskev. I can recognise some commonality going on, and this is better explained actually. It might not seem it, but it's better explained about how you get these fast beta transmutations owing to the density of polarized electrons. They're polarized. And the availability of low-lying final electronic states for the stripped nuclei. So because there's no electrons, you can imagine that the electrons that are effectively in the nucleus under the onslaught of everything else going on are a little bit unstable. So the Darmstadt process, high-intensity closed magnetic flux lines, which we know we have, also form when 2 heavy atoms or ions collide at energies ranging from kiloelectron volts to hundreds of kiloelectron volts from the sudden variation of radial electrical field around the center of mass as the nuclei approaches or move away from one another. Okay, from the shielded potential. Where mu is the reduced mass, one deduces the relative velocity as the nuclei approach, blah, 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 and the radius, okay. Let's see some meat on the bone here. Again, all the work is done here, and like I say, I'm reading it now for the first time, so maybe it's valid, maybe it's not, but other people who like this sort of thing can delve into this. This mechanism produces magnetic fields high enough to condense higher order mu or quark composites, rho-bosons or deuterons. In the case of a condensing electronic system, such collisions can help nucleate subcritical field to critical intensity. In the case of condensing, so basically, SV Adamenko says you get like a quark soup. In fact, Ken Shoulders describes it something like that. So these are condensates of subatomic particles. Okay, so we're getting down to full-on nuclear collapse here. Within high axial magnetic field, the opposing adjacent flux lines join in a wrapping kink at the equator and become open-ended as their intensity decreases further along the axis. Thus, colliding pairs of heavy nuclei in the axis of an electronic filament condensate may kink or disrupt its inner field. In this case, we take blah 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 for the extreme ring. Right, neutral threads. A metastable neutral state can be strongly magnetized, approximately BCE, self-confining, self-regenerating fiber made from confined twirling photons. This will please you, Axel. In an electron-positron magnetized plasma with quantized magnetic flux. Rojas et al. Showed that such photons acquire mass and magnetic moment of about 13 times the electron anomalous value. Although some confinement would be ensured, that would certainly be a heavy electron mass. But it's a photon. The photon is acquiring a mass and magnetic moment about 13 times that of an electron anomalous value. Although some confinement would be ensured by a refractive index of such a system in self-regenerative resonant transition, it is expected to be highly unstable owing to tunneling. I've got to have a conversation with this guy. He sounds like a scream. I've got to have dinner with him. I might have to find my way going down to Greece and chewing the fat over something. The photons sharply decrease the magnetization to mass energy ratio. Okay. Neutral threads of coaxially bound charged states. Long-lived neutral superconducting magnetized states in quasi-monopoles. Quasi-monopoles, pseudo-monopoles, quasi-monopoles. This definitely looks like this guy's had a conversation with Roitskev. Seem to be an experimental fact. Okay. From where? Karopoulos, where is it an experimental fact? Building them from positronium-like entities as well as confined photons poses the problem of their stability. An alternative is to consider bound condensates with different quantum numbers, such as a concentric ferromagnetic configuration built around higher order electronic core and having a lower order positronic vector sheath. Easy for you to say. Assume open high order electronic filaments of this have condensed within an axial magnetic field, the greatest electrical potential and gradient being at their tips. More electron-positron pairs will be created there. So this, if you're creating electron-positron pairs, one might say that this is pulling this out of the vacuum. The electrons condense or are expelled, while positrons wrap themselves round the filament until they sheath it. Initially, this resembles a giant atomic entity, because the endings of the inner core have the highest electric as well as magnetic fields and gradients. The density of screening positrons will be significantly higher there, condensing into vectors enclosing some of the flux that returns to the other ending via the surrounding space at their lower, we're over halfway, you'll be pleased to know, at their lower critical field, with some flux escaping outwards from the tips. Initially confined to the endings, the positronic condensate spreads to cover the entire filament so that ferromagnetic configuration emerges. It is assumed to be metastable because the positive sheath vectors cannot immediately annihilate with their higher order central counterparts, nor can the latter form positronium states with external electrons, or the central bosons annihilate with any surrounding giant atomic positron clouds. Later on, the binding of nuclei at the endings, as well as the embedding of slightly negative system into a ferroelectric, may further stabilize it. The negatively charged central core constitutes a trap for nuclei. I like this. The negatively charged central core constitutes a trap for nuclei. Okay. Because the peripheral positron condensate lowers the overall charge, these keep safer distances from one another, as compared with those entering a newly formed electronic condensate, which partake in fast nuclear reactions and can be ejected, so that a quiet metastable neutral magnetic polymer is possible. Kenneth Shoulder's grey exotic vacuum objects seem to be just such condensate systems, involving a positron vector sheathing round a higher order electron core. The many phases and transformations seen in exotic vacuum objects involve partial decays, sheathing, transitions to lower or higher order, or to negative mass. Okay, so I'm kind of getting what he's done here. I hope you're getting something here, but he's building an argument. I think this must be a later paper from the previous one. And understanding, and he's brought on some other learning. He's obviously been inspired by what he's read from Kenneth Shoulders, and he's looked at other information and evidence, and he's working with that. The dynamics of negative masses, whereas straight tunneling from that to the decaying of that state, plus radiation only involves a virtual transitory state, persistent states within M0 to approximately... is that Omicron? It might be Omicron. Omicron minus... sorry, that's going to get the video banned now. are a conundrum in thermodynamics and causality in approaches that reverse the temporal evolution, and problematic as regards to the apparent charge non-conservation in those that transfer such states unto mirror folds within non-interacted charge. The energy is bounded from below that by limiting a state that also happens to have vanishing density and a limited lifetime. There are many ways of dealing with negative masses. For instance, one may simply rule them out for states that have exhausted all their positive electromagnetic energy. But this is not necessarily the case. Ultimately, experiment decides which approach is relevant. Yes, I agree completely. Ultimately, experiment decides which approach is relevant. Yes, I can get behind that. Okay, so go for the rule levels of so he's talking about consequences of negative contrarian dynamics of negative masses. They accelerate or recoil in the opposite direction in external electromagnetic fields, so that neutral system of ions or positrons and negative mass electronic states appear to move as though they were entirely positively charged. Okay, but they're negative mass, but they appear to move as positive charge. Okay, it might self-accelerate without the system gaining momentum or kinetic energy. Negatively charged entities may cluster together internally instead of a centrifuge acceleration. The spires of a negative mass solenoid feel a centripetal one and tend to separate longitudinally from one another as their magnetic moment diverges. Such states would gravitate towards Earth and orbit. Such states would gravitate towards the Earth and orbit. Okay, I think he's missing a knot here. Such states would not gravitate towards the Earth and orbit, but repel it. Okay, I think there may be a knot missing in that sentence. The eventual decay of critical B to BC negative mass states frees its components from bondage and scatters them. At this point, these reverse their masses, velocities, and any runaway stops, while charge and momentum are conserved. The renormalized magnetic energy and missing or negative mass is analogous to the classical vacuum that forms inside the core of vortices, which the renormalized magnetic energy and missing or negative mass is analogous to the classical vacuum that forms inside the core of vortices, which are visible singular objects, while the missing mass and momentum become delocalized within the surroundings. You'll like that, Axel. You'll like that. If you're still with us, you'll like that. Upon transitional decay, this energy relocalizes. I think probably this phrase here, the renormalized magnetic energy and missing or negative mass is analogous to a classical vacuum that forms inside the core of vortices, which are the visible singular objects, while the missing mass and momentum become delocalized within the surroundings. Upon transitional decay, this energy relocalizes. So I think that might be Axel's favorite phrase of the evening. If you're still with us, Axel, I would be interested to see if you like that. Okay, extreme rings. The extreme M0 is approximately Omicron 0. Maybe it's, yeah, anyway. Magnetic, I've had to say it more than once now. Magnetic dipole ring of that is stabilized by a charge spec and some peripheral ions of total charge. Blah, 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 centered at R equals naught, so that U is slightly positive. The spec forming within the ring a harmonic oscillator. The stabilizing effect results from the Coulomb potential well, because the states with the increasingly negative masses have smaller radii that resist being reached. So long as the positive spec is there, blah, 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 blah. Okay, collective effects. At some point, owing to the collisions, at some point, owing to the oscillations of increased amplitude, a stabilizing charged spheroidal or lenticular cloud with internal cohesive forces is drawn far enough from the center of an M equals that thing again, plus extreme ring or that thing, M and that, peripheral toroid with some screening ions, that such rings may invert their mass, emitting this photon pairs from a negative U having become positive. Owing to the negative mass, they now run away from the positive objects that they attracted and cluster towards similar negatively charged entities. The oscillating system, besides new motions in external fields, starts to move of its own, chasing itself erratically, oscillating or stopping upon transition or decay. A medium comprised of a large number of similarly oriented mesoscopic oscillators, synchronized by an external electric field and its fluctuations, thus decays into a unidirectional plasma sandstorm with giant charge oscillations and unexpected motions. This, my friends, is starting to sound like strange radiation. This is typical behavior of Earth lights, ball lightning, and exotic vacuum objects, as observed by Kenneth Shoulders. When a newly formed closed flux 2bc/3 toroid evolves to a smaller mass as its large radius shrinks, the strong electrical pulse that results induces neutral metallic grains to discharge by seeding electrons to the condensates, thereby gaining a positive charge. It causes a similar collapse in neighboring rings and orients them so that a system of large aforementioned oscillators is prepared. Metallic grains may also seed electrons to extreme toroid by simple contact or approach, the latter also gathering electrons from the atoms they confine. Upon collapse, metastable extreme toroid induce a substantial magnetic cooling. Upon collapse, metastable extreme toroid induce a substantial magnetic cooling. Within the Euler-Heisenberg renormalization scheme, the magnetization of the vacuum above BCE is expected to be free. In extreme long solenoid states, this represents up to 215 mega C squared per pair. I'm not quite sure what we're looking at there. Is that 215 whatever per pair? It remains to be seen whether this can actually be tapped as free magnetic energy. Interesting. Other considerations. What is the precise energy balance for charged metastable state? La da 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 da. Okay. The limited lifetime of such entities. We're 2/3 through. Is everyone asleep yet? Back. What did I miss? You missed some quite nice things. Not a lot, but quite nice things. They're talking about here, which is relevant to you, David. The oscillating systems, besides new motion in external fields, starts to move of its own, chasing itself erratically, oscillating or stopping upon transition or decay. A medium comprised of a large number of similarly oriented mesoscopic oscillators, synchronized by an external electric field and its fluctuations, thus decays into unidirectional plasma sandstorm with giant charge oscillations and unexpected motions. This is typical behavior of Earth lights, ball lightning, and exotic vacuum objects as observed by Ken Shoulders. This might explain the coherent matter wave type movements that we have seen in your reactors. Okay. All right. Good. And I'm not bored you to sleep. This is what I have to do sometimes. I have to actually read things that no one wants to read and try and find out what is trying to be said and whether it's useful. Okay. Oh, hold on. Hello. Okay. Similarly, Okay. I'm going to step back because I've just spotted something that's really cool here. Okay. Okay. As a result, open n equals 1, b1 is 2, blah, blah, blah. Screened filaments longer than about 430 to 500 microns are stabilized in the field at the Earth's surface and in its immediate vicinity in the solar system, respectively. Similarly to a compass needle, they align their inner field with an external one and strengthen it further along their axis, which allows for exotic vacuum objects enhanced magnets. The open, neutral, metastable filaments is a pseudo-monopole pair. Hey! Similar to a Kynes phallico-soliton. What am I talking about that? Well, what are we talking about there? I think we need to bring up Lion, mining diamonds with Lion. Lion, is it in here? I think it is. What is a phallico-soliton? Well, this, my friends, is what you're seeing here. It's what you're seeing here. And these are your solitons. And here it is. Toroidal vortex soliton pairs. This is your kind of phallico-soliton, like, but in a hydrodynamic sense. And this was on the X-rays. And this is analog in water. And here you've got our one on the sun. And this isn't a soliton pair. This is a full flux loop. You've got the ones going through the material here. Anyway, enough of that. Good, excellent. There we go. So phallico-soliton. Go and look up phallico. Let's look up phallico-soliton. Anyway, we're going to go straight to. There's this. I don't know if anyone's heard of it. There's this site called Google, and you can put search terms in there. It's quite amazing. And it tells you all the things that they want you to know and none of the things that they don't want you to know. Okay. What's a phallico-soliton? There we go. There's a phallico-soliton. And look, there's your pool rings. Phallico-solitons. There we go. Can you see that? Can you see what it is? Yeah, that's a phallico-soliton. Hey. In a pool. Here's topological defects. Phallico-soliton. Particles in the pool. There we go. There's particles in the pool. Have we got a picture of a phallico-soliton? No. Where did we see that here? Open link in new tab. No, it's not going to give it there. Open image in new tab. Open image in new tab. There we go. Not the best image. There you go. There's your phallico-soliton. This is incredible for me. This paper's got to be middle of the 2000s. And we saw all of those solitons on the Lion reactor and whatever. Magneto-hydrodynamic. Hydrodynamic. Surface 2D singularity. Okay? Yeah, one is a north, one is a south. Okay? We got it yet? Are we there yet? The magnetic poles observed by Arutskiev, et al. After strong discharges would then be open screened filaments of several microns in length. Yeah, you're not wrong. That's what you see in mining diamonds with Lion. Look. Let's see some. All right, have we got it there? Oh no, it's not in that one, is it? File open. No, I haven't got it in there. Oh yes, I have. There we go. Oh no, it's not that one. Yes, it is that one. This'll do. We have this is our cannon here. It's not the right slide, but this is a lot of microns, in fact, in this case. But we have other ones that are smaller. There's one over here. I haven't actually got the right one for you, but you've seen it before. You've seen the solitons. That's what you're seeing here. When I called them cannons, and you've got a north pole here that's throwing out the material, and this is the south pole here, and this is your soliton. And this was the material that was being swept around there in a very, very small structure. Okay, and there's several other ones. There's another one here. There's one over here. But anyway, you've seen these before. All from the Lion reactor. Thank you, Lion. The magnetic poles observed by Rutskov et al. After strong discharges would then be open screen filaments of several microns in length that move in the magnetic gradients near the ferromagnets that then capture them, rather than free magnetic charges. The limited lifetime of such entities of about a day, the limited lifetime of such entities of about a day within iron, as well as their decay, would suggest it, seeing as an elementary particle, the limited lifetime of such entities of about a day within iron, as well as their decay, would suggest it, seeing as an elementary particle, especially one carrying a magnetic charge, should be stable. It is therefore expected that a material with anomalous magnetization will not leave the typical signature of monopoles when passed through a superconducting loop. Okay, that's interesting. Okay, so what this implies is that we might have a method, if you happen to have a superconducting loop handy, like, I don't know, an MRI scanner. If you happen to have a friendly medical person that would allow you to pass your material that's been exposed by whatever process it is through an MRI scanner, you might see something different going on. Okay, open neutral filaments shorten progressively or decay under influence of acoustic perturbations. Interesting. Open neutral filaments shorten progressively or decay under the influence of acoustic perturbations that force them to tunnel to BC, so that the longer shielded filaments have the longest lives, which may reach days or weeks in suitable environments. So this is what we see. This is what we see, because let's go back to Lion again. Let's go back to Lion. I'm really, what I'm reading here is, this is awesome. What I'm reading here is just awesome. Why? Why is it awesome? Because of this. Lion had his reactor in here. Hot, that's not it. This, by the way, was the bulb, the exact bulb, the 12 volt, 20 watt bulb that was lit for about half an hour. The core was taken out and it was put into a biscuit tin like this souvenir British biscuit tin, using dental x-rays, and this is the x-rays here. And when we looked at those dental x-rays, you saw these solitons. So this was, I'm absolutely blown away. I'm almost in shock right now. And I don't know whether to laugh or cry, because this is from the mid-2000s. This is the mid-2000s. They're saying something that's akin to intense magnetic phallicosolitons is generated and can live for days to weeks. And that would explain, I have phallicosolitons there, my friends, and that's what I assumed these could only be. And it's coming from a reactor which had the ability to produce EVOs. We know that. This is absolute 100% proof that Lion works. 100% proof. What you're seeing right now, I did not know. I had no idea that this was here. I had no idea that this was here. How I came to this conclusion was, I thought, what explains this? I'm seeing these pairs. They're definitely pairs, and they're different scales and so on. And they just look like things that I've seen on the bottom of a swimming pool. And then I see this, and then I learn that it's called a phallicosoliton. And I assume it's something similar to this, because it must be some sort of magnetic loop. I'm really happy. This particular paper has absolutely got me totally stoked, because I have to share this segment with Lion. I don't want to cry now, but here we go. That the longer shielded filaments, and these are definitely longer. These are long. I mean, these are long. Have the longest lives, which may reach days or weeks in suitable environments. And this suitable environment here is what? It's cupric oxide. And if you go and look up superconducting materials, cupric oxide is something that does this. It is known to be a superconductor. And by the way, this is the little image down here that I have on remoteview.icu. So in this particular material, we know for certain that it had these structures. Absolutely, certainly had these structures, because there they are. And this is what, I think this is 20 millimeters by 35 millimeters. And so you can see how big these solitons are. They're freaking huge. They're huge, and they would last a long time. Lion has to see this. I'm blown away. This is probably the biggest day for me in studying Lion since I looked at these X-rays. Absolutely blown away. Open neutral filaments shorten progressively or decay under the influence of acoustic perturbations. So if you wanted to break down these magnetic soliton structures, you would hit it with sound, right? But if you didn't want to and you charge pumped it, which he was doing, the longer shielded filaments have longest lives, which may reach days or weeks in suitable environments. You are absolutely 100% right. We already had the proof, although you already had the concept. They may also see formation of new charged states. Phenomenology. The monopole endings of open filaments in motion. Oh my God! Come on now! It's like, this is Christmas to me. This is literally Christmas. The monopole endings of open filaments in motion. Monopole endings. What? You mean like... Oh dear. I'm just totally blown away. I'm literally in shock right now. I'm literally in shock. The monopole endings of open filaments in motion, as well as their negative core, can ionize atoms and thus accelerate their beta decay. There we go. The monopole endings of open filaments in motion, as well as their negative core, can ionize atoms and thus accelerate their beta decay, and retarded neutron emissions rates by freeing the required low flying state. So that's where your neutrons are going, Axel. That's where your neutrons are going. A charged condensate in a dielectric, gaseous, or ionized medium tends to ionize it strongly. As Messiats, there we go. I knew he was looking at Messiats when we saw what we saw above. Looking at it, cut and paste. As Messiats et al. Have observed in cathode hotspots and during sputtering, or Donitz et al. In drift tube, low pressure reflex electronic discharges. The anode hotspots of wire electric discharge machining are cathode hotspots that form near an anode's Sorry, I'm blown away by this and by this. It's almost too much for me. This is Christmas for me. I almost can't read on. Sorry, but I'm going to finish it. We're most of the way through now. I'm now excited to see what other insights he has. Hotspots form near anode's layer of oxide, carbide, or nitride, depending on the dielectric, which grows before the discharge establishes itself and self-interrupts. So the resulting energetic ions are projected against the anode. It is then observed that machined parts from normally non-magnetic materials, as well as the carbon residue from the oil, become ferromagnetic from the accumulation of magnetic filaments. There we go. There's our magnetic copper, our magnetic materials that you would get in John Hutchison effects, and the carbon that we see becoming magnetic, for instance, in the Nova reactor. There we go. In fact, a portion of the field of permanent magnets can arise from such an accumulation of magnetic and electrical circuits, or the relative motions of magnets can be optimized to generate copious amounts of such condensates and harness the resulting electromotive or mechanical force either from high-frequency superfacial discharges or from the combination of material. I think there's some very important information here, guys, that we're going to have to look at again. Or from the combination of materials, texture, Foucault currents, microwave oscillations, and condensate channels that act as femtoelectrode segments in the bulk. Magnetic cooling results when the field collapses. There we go! There we go! Magnetic cooling results when the field collapses. I'm pretty sure that what was going on in Lion was absolutely shed loads of these solitons, right? And probably when these structures collapsed, they caused this material to become glassy and intensely cold. So you've got another mode of cooling here. You've got the ions wanting to get their thermal energy back, the electrons wanting to get their thermal energy back to compensate for the photons that they lost, as they lost a fraction of their mass through these photon emissions, these 2 keV photon emissions, up to keV. So from the UV, EUV through to the soft X-rays of 2 keV. And you have this magnetic cooling effect. So that we've now got two different modes by which the line could have frozen. Condensation into filaments occurs when Z-pinch discharges break up owing to the sausage instability. Everyone likes the sausage instability! This creates very localized and dense discontinuities that explain the substantial fusion reaction and neutron emission rates that have been observed when such discharges break up. It's when they break up that you see the fusion reaction and the emission rates. For instance, Rambart's analysis of such discharges in deuterium concludes to a medium having a fractal dimension of 1.9 to 1.6 with 10 to the 3 to 10 to the 4 electrons in a sphere of atomic radius 0.53 of an angstrom. In agreement with the present paper, similar phenomena occur in metallic conductors subjected to high current spikes, like as in beryllium. They fragment from the Laplace pinch pressure. This is actually like Wendt and Irion, and also like Reutzker et al. They fragment from the Laplace pinch pressure, as well as from longitudinally repulsive electrical forces of their positively charged core and negatively charged surface owing to the skin effect, and can then condense magnetized electron pairing states as the current is reflected off the micro discontinuities of the freshly broken conductor. Similar occurrences were observed by Messiat et al. Hey! And the Correas, there's the Correas brothers, there they go. And they did it with spiky electrodes, so they had multiple EVO emitters on their devices. And Messiat's described that as the way to produce these things. Ectons, but they're actually EVOs. During the sputtering of materials in vacuum from small droplet instabilities in the hot spots that appear on a solid plane cathode, thermal energy being released from the nuclear reactions in newly created EVs. And by Donitz et al. In electronic pulsed reflex discharges in low-pressure drift tubes, whose pulses, first squeezed by the mirror charges in the drift tube, later form shock waves and electron filaments, once reflected at the ends, and the nonlinear discharge phenomenon having been initiated. The center near the axis of the ring and the reflecting electron depleted, blah, 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 accompanying fermic states. As the vector condensate forms as original waves amplified, soon the electron condensation band shock waves. especially when the bosons form rapidly metastable, dense, highly magnetized, electronically screened state in which the nuclear reactions and beta transmutations occur. The charged electronic condensate, surrounded by its accompanying Fermi fluid, being a dense source of polarized electrons. Polarized electrons. Why do we see polarized light structures all on our material? Intense magnetism, polarized electrons. Perhaps that's why. Interacting with highly polarized nuclear targets. The stripped atoms are then expelled as multiply ionized entities observed by Donetz et al. So if you've got the atoms completely stripped of their electrons and they come out, you end up with this. You end up with these flashes. Get ready? Ready? Boop, 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 boop. There you go. Evo blaster. Wonderful. That's a lovely blast at the beginning there. Poo, poo, poo. The emission of energetic nuclei, 16 megaelectron-volt protons, from the cathode hotspots of Tesla coil terminals had already been documented by Gustav Le Bon at the end of the 19th century. The emission of energetic nuclei, 16 megaelectron-volt protons, from the cathode hotspots of Tesla coil terminals had already been documented by Gustav Le Bon at the end of the 19th century and is typical, though neglected, component of the ionic wind bursts that emanate from negatively polarized tips or surfaces. This is your home ionizer. This positive ionic countercurrent heats the cathode on the one hand, hence the aptly named hot spots, and on the other contributes to the observed negative resistance of the discharge by an actual electromotive force. It says polarized electrons. It specifically says polarized electrons. Bob. Okay. Anyway, the paper is linked in there. Okay. In the presence of an axial magnetic field, this is important. We want axial magnetic fields. There was an axial magnetic field in the PAP engine. I believe that an axial magnetic field may be useful in the Xeno experiments. Even a relatively modest one, a newly formed singularity, rather than close into a small ring, may, owing to the flux compression in the current sheet, converging towards the pinched singularity from the conservation of angular momentum in peripheral electrons having high axial Landau states, and to the further amplification of the induced magnetic field by emerging condensate, form a solenoid that soon uncoils into an open filament under the influence of both its charge and the outer axial field that stabilizes it. It is therefore more active in its initial stages and with respect to induced fission of heavy nuclei, pair creation, this is electron positron pairs, and ionization at its endings, and eventually decays into a long monopole terminated quasi-neutral filament once its charge is shielded. Monopole terminated. This is what we see in Lion. Interestingly, the observation of monopoles by now this is fair actually. Ehrenhaft in the 1930s was the first person to observe strange radiation-like tracks. I learnt this after I started finding strange radiation tracks, and I had a discussion with Dr. George Eagley, and he says, I've seen these sort of things before. I'm sure Ehrenhaft did this thing. And it's in the 1930s. Interestingly, the observation of monopoles, and I think he did a monograph on that in Fusion Technology after our conversation. He's an editor of Fusion Technology. Not Fusion Technology, Infinite Energy. Sorry, Infinite Energy. Interestingly, the observation of monopoles by Ehrenhaft in 1930s and by Mikhailov I don't know whether that's Mikhailov-Solin, but anyway, Mikhailov, since the 1980s, involved particles created by the sputtering of ferromagnetic materials in electric arcs. While those recently observed by Oroitsev et al. Were produced in exploding discharges, titanium sheets in water, and only later bound themselves to ferromagnetic materials. In the observations of Mikhailov, an open magnetic filament oriented in the homogeneous magnetic field, terminated by magnetic poles, one of which is bound to a ferromagnetic particle, will see the magnetization of that pole enhanced. The strength of the apparent magnetic charges when observing a magnetic dipole will depend on its length, its magnetic flux, on the gradient of the external field, and whether some flux is enhanced or returned by a nearby ferromagnetic. Oroitsev et al. Observed caterpillar-like dual... Hey, there we go. I knew he was... The maths above was pointing to him trying to explain strange radiation tracks. Okay, here we go. Oroitsev et al. Observed caterpillar-like dual traces in film that could be ions ejected from the poles terminating a large end-screened filament. The fact that the anomalous magnetization created by such poles in iron disappears after a few dozens of hours supports the view of a non-elementary particle whose magnetic charge would have otherwise been conserved. It indicates that the filaments linking the poles decay, with lifetime probably proportional to their length. Screened filaments may carry small, longitudinal, reversible magnetoacoustic excitations between their poles, so long as their accompanying magnetization does not exceed 2bc/3 by enough to make the state tunnel through the many neighboring non-integer flux states, acting as confining potential barriers. The charged vector condensate filaments are superconducting and ferromagnetic. Viewed from a distance, the apparent density of charge of a quasi-neutral condensate system can be low and similar to that of some moderately shielded electrons. Because of their low apparent charge in the quasi-absence of a Fermi fluid, and in a well-shielded environment, greater acoustic perturbations are allowed before the constituent charge states tunnel to BC. Grigorov et al.'s polaron embedded long-lived filaments. Oh, I can see Axel getting excited again. Long-lived filaments would be examples. Early measurements by George Eagley, there we go, there's George Eagley, and G. Vertzi of the anomalous biomagnetization of various samples showed that metals retained anomalous magnetic properties less than 48 hours. A span confirmed by Oroitsev et al. So 48 hours is also the length of time that Bogdanovich et al. Observed these long-lived plasmoids, while wood remained magnetic for about 40 days. In line with Grigorov's experiments, in these tiny magnetic filaments were first produced in a polymer precursor by high-voltage electrical discharge. So, given the fact that John Hutchison was really taking this to the max, one can imagine that some of the magnetic anomalies that he observed and these non-magnetic materials pulling together or falling apart would have been due to these structures maybe coalescing and so forth. Anyway, the viscous dielectric was then electrically polarized by a high intensity, lower voltage electrical current for several days so as to assemble the small conducting magnetic filaments into longer threads. Interesting. The viscous dielectric, was then electrically polarized. Well, all of this is, what you're seeing here is all going on within Lion, by a higher intensity, lower voltage electrical current for several days. That was going on in Lion, so as to assemble small conducting magnetic filaments into longer threads. Right, well, all of that is present in Lion. All of that is present in Lion. Okay, Finally, the dielectric was polymerized with its conducting filament, reinforced by strong currents. Water, because of its high dielectric constant, is particularly well suited to a similar process, whose initiation is expected to occur naturally when flowing through dielectric rocks or condensing within storms. There we go. When flowing, there we go. They are saying effectively here that the cause of strange radiation can be synthesized within storms and with water flowing through rocks. And therefore, you are going to get the things that can transmute matter. And I imagine that something similar could be occurring in ultra and other water cavitation experiments. It can be subjected to strong electrical stresses and discharges. The artificial equivalent would be the Mayer cell. Stanley Mayer, there we go. Hey! Besides atmospheric water is likely to condense preferably about the magnetic filaments from solar or terrestrial storms, from the Wilson effect of ionizing magnetic pseudomonopoles in motion, eventually forming magnetic polymers. The final phases of the Grigorov procedure are quite similar to the otherwise incomprehensible Joe cell. we've got a couple of different sort of HHO sort of things going on here. It is noteworthy that the latter induces both an anomalous conductivity and dielectric breakdown in the liquid, mist and vapor phases of the charged water at low and high voltages respectively. The formation of anomalous ferromagnetic residues or magnecule chains in the initially non-magnetic compounds, as well as other anomalies. Magnecule, this sounds like centilli, okay? And we've seen structures formed in HHO experiments, and other people have seen this, for instance, Randall Mills' brilliant light power. Okay, because the orbital of a charged scalar round a central ion is generally diamagnetic, only a current-carrying superconducting cyclic molecule ring with positive ions on its periphery could display attractive Laplace forces. Okay, I'll take your word for it. Because such magnetic polymers appear in a wide variety of materials subjected to or having been in the vicinity of discharges, including dielectrics such as wood, water, hydrocarbons, gases, metals, and because of anomalously high energy content in subsequent chemical reactions or combustion, the hypothesis of an orbital molecular ferromagnetism must be discarded in favor of nuclei screening a charged magnetic thread. The resulting filaments and pseudomonopoles, once activated, induce nuclear reactions, the radiolysis of water or fuel, as well as enhanced rates of chemical reactions, notably in spark gaps. Well, I can't remember his name offhand, the Russian guy. A similar reasoning applies to the biological ferroelectrics subjected to high local electrical stresses and currents in physiology. This suggests a role for screen filaments and their magnetic polymers in biology that could explain the puzzling biological transmutations observed by Kervran in the 50s. Are we there yet? Magnetic boson and binding alternatives. Charged bosons could result from bound states between an electron and a neutrino with parallel spins. Because they are different eigenstates of isospin, Pauli's exclusion principle holds. A. Barut found quasi-point-like magnetically bound states between an electron and half the spinor components of a Dirac neutrino, with a vanishing anomalous magnetic moment, which could explain the parity violation of the weak interactions. Such a vector has Q equals E, but is expected to have high mass. A bound state between a neutrino mixture with rotating electric dipole and an electron at the same zeta Biriggang frequencies but complementary dipole orientations or phase is also expected. The resulting vector has Q equals E and M approximately 2me in the neutrino theory of light. This amounts to a binding between highly localized rotating half photon and an electron. Okay, this would also please Axel if he was still with us. He would very much like this. Okay, all right. Other approaches lead to tightly bound electron pairs with parallel magnetic moments at distances below the Compton radius, at which the Pauli exclusion principle no longer holds in strong fields, especially above BC. So that's what he was describing in the first paper, I think. One idea that underlies this paper is that the spinning electron behaves as a current in a conducting loop. So it itself is like a soliton. So that two attract one another at close range. That's interesting. Yeah, okay. Two similar, isolated, co-moving point or spread charges experience no magnetic attraction and are, in any orbital motion, mutually repulsive magnetically. Ferromagnetism cannot arise only from the orbital motions of charge round a positive centre, because any such motion is dielectric and diamagnetic. Therefore, Poincare's unit charge spinning ring electron of Compton radius, although it has the correct magnetic moment and flux, would be diamagnetic instead of paramagnetic, and allow neither ferromagnetism nor tight bound states. It follows from the Dirac equation that the electron spins with half Compton radius is that at twice the Compton frequency, that the anomalous magnetic moment results from the orbit being approximated by the edge of a Mobius strip of width that. The half Compton radius shrinks with... now I'm seeing the work of Stoyan-Sarg in Basic Structures of Matter, by the way. The half Compton radius shrinks with the relativistic factor and momentum. Unlike the width of the strip, their associated magnetic moments and fluxes become comparable at the strong scale. When the poloidal flux is relativistic invariant of one quantum, the toroidal flux of the electron is only 2 alpha squared. That value at rest. The gyromagnetic factor of the two that induces the correct magnetic moment involves a current twice that of the unit charge, owing to Zitterbewegung. The charge spins in space accompanied by positive and negative energy oscillations in the frequency of that. In other words, half magnetized para pair in the zero Landau state contributes to the current and magnetic moment without affecting the spin. This doubles the effective current because of the counter-rotating positive current, additional balancing negative charge, and mutual apparent Lorentz contraction of the counter-rotating sources of retarded potentials. An attractive Laplace magnetic force results as within and between conductors. This is why collinear electronic spins, magnets and electromagnets attract one another, and why the Coulomb repulsion between electrons is overcome at close range. Acknowledgements. Thanks to Leonid Roitskev for many for many interesting discussions and concerning his remarkable experiments, and to H. Lane for having drawn my attention to Rambout's papers, and to interesting references and documents concerning Earthlights, and to the work of Messias. And there's the references. So there we go. We managed to get through it. Thank you for listening to this today. I think we've had a good number of wins. We've understood a potential mechanism to explain the lack of neutrons, the lack of ionizing radiation, the thermal output that can be, or rather the photonic output that then can be used to produce electrons. And we discussed that by lowering the photoionization limit by using copper oxides, for instance, as we tried in the Vega experiments, which produced those beautiful micro ball lightnings within the copper oxide. We did a study on that, and the ball lightning there, the perfect toroid that you saw, and also these magnetic flux loops, these soliton pairs that we have explored in this paper that we first saw on the Lion experiments way back in 2017 into 2018 and started this major part of the journey. These things are very coherent with what he's saying, that word coherent, and that the process can cause transmutation and even down to the point of causing bosonic clusters out of subnuclear structures. This is consistent with the observations of S.V. Adamenko, with the observations of Matsumoto, with the observations of Ken Shoulders, and the fact that matter can be transported out in a neutral thing. This is able to explain the disappearance of matter from inside Matsumoto's experiments and from the 1979 onwards work of John Hutchison. And so what you're seeing in this work today also gives you the opportunity to use this technology for propulsion, but we're focused on, with the Xeno experiments, on the kind of weird heat pump and up production of higher energy photons. So when the EVO is formed, so we'll go back to the first paper, and we can pull up this image here, which shows that when you have your wetted electrode and you put a negative pulse there, you produce your white EVO, and it radiates the 2 kiloelectron-volt photons, and these can come to your half negative biased tube. And this is a low pressure, and I would have xenon in here. This would be mercury wetted tungsten, and this tube I would preferentially sputter or coat with yttrium oxide. That gets us down to within a hair's breadth of the photonic low photonic energies of 2 eV. Which that would, if you've got 2 kiloelectron-volt photons coming here and it's bouncing around within this tube, that could release potentially 2,000 electrons per emitted photon if you've got 100% feedback, and that would give you 2,000 electrons per photon that comes out, and you're going to get a whole bunch of these coming out as this EV comes down here. And then when it gets to here, the electrons capture the thermal energy. This is the thermal energy coming in, which is making the bulk parts of the material of your reactor cool, and the extra electrons are coming down here, so you get electron gain from that process. I also talked about the traveling wave, one that is in his paper here, which you can see if I switch my camera over here to maybe there, you can see this in his patent, which is patent number 5123039. You should choose to read that. I would recommend reading that. And in here, it talked about how the intense magnetic fields are formed and how you get magnetic cooling as well. And that's that. And at the start of the presentation, we started out by talking, where is it? About the Vega Evo Blaster again, and the significance of this, and the EMP one of it, and this phrase here by questioned by Nancy, and when they explode, they're gone. And Ken says, in that case, they explode, break down into lots of little electrons, lots of ions. That's when the flash of light is. That's what the flash of light is. That's the ionic spectrum of the explosion, and it's no more. And that is what you are seeing here. You are seeing the ionic flash, as all those electrons have to go and reconstitute those atoms that have had their electrons removed. We talked about the phallico-soliton. We talked about the lion and how important that was to the overall understanding. And we talked about the life cycle here and the Xeno project here, which I recommend you can get involved with. And I roughly talked about the EVO life cycle here. We talked about ways of getting energy from nuclear reactions, and since we got tungsten electrodes in here, and with a mercury and xenon low pressure HID bulb, we have that, but we have to have higher pulse currents to initiate the discharges, because it's a high pressure environment and not a low pressure environment like Ken Shoulders used. And we talked about these different methods that were established by the team at Dubner over 9 years to produce these birdies. And the birdies are able to carry ions. These are the ions that were carried in them, and the birdies look like this here, and these are the magnetic monopole structures, and they are absolutely and completely identical to what you see here in the lion experiment, when we can show that. Not that one, in the lion experiment. If I can get it. In this one. So these are the birdies, and that, my friends, is why I have this image. If I actually go in there, maybe I can get it up bigger. I'm going to make this image a bit bigger, because I know the data's better in the actual. There we go. I've just tweaked that image there. So this is actually the one I have on my remote view. This one here. So you've got the kind of like black hole in the middle, and you have the bit from the outside. And there we go. This is the same as they're observing, but in a slightly different sense. Okay. So any questions? Yeah, it's you imagine when I saw the enormity of this back in the beginning of 2017, going from 2016 into 2017, the enormity, and I thought, how is this going to be got across? It's going to need hard, physical, repeatable evidence. And yeah, I had read that first paper that I've shared with you today back then, and it was kind of like, it was just within a whole of that, reading that, learning about ball lightning, seeing what we'd seen in our experiments with gamma in 2013 and signal in 2015, and then being with Piantelli and all of that mishmash coming into 2016, finally getting to meet George Eagley in Budapest, learning about ball lightning, the connection with ball lightning to shoulders, and then coming into the shoulders Hutchison connection, and then reading this paper today that I read then, and then it was just such a mindstorm. It was just a mindstorm of thank you very much, Lou. That's really kind of you. An absolute. So someone's given me a super chat. Wow, it was an absolute mindstorm of things, and I just thought, how is this going to be got across? It's just so enormous. The implications are so immense. How can we make simple experiments that are going to prove this, that people are going to believe? Because no one's doing it. No one from 2012 to 2000 and late 2016, going to all of the conferences, being as full a member as I could in the Lena community. No one mentioned shoulders. No one. No one at all, or any of these people that have observed the same effects. It's just crazy. Of course, now I understand why. I've learned why along the road. Yeah, so there's several experiments. So go and ask questions in yes, David. This tech makes so many things you were taught in school impossible possible. Yes, it does. It does. Miscal, if you want to add to the live document, go to the Zeno document here. So if you go to quantumheat.org and you go to the top experiment and updates, you've got the live document here. And down below, we've got the chat here, so you can come and chat. So I am intending to use people's contributions here, and I hope people will consider people's contributions to the live documents, to experiments, and to the commentary here as value added to the process of producing a valid solution. Which would then qualify for the proposed million pixel accelerator down here, and of which, as I said, the intention is to whatever the prize fund is to be 75 to the person that hands over a working unit with full descriptions and so on. Oh, guys, you're making me blush. That's more super chats. That's more super chats than I've had since the beginning of running this channel since 2012. Wow. Okay. Thanks, guys. So, yes, I'm aware of Wilhelm Reich, and Wilhelm Reich's Ugon energy was effectively these cold neutrino clusters, in my view, and Wilhelm Reich is, I think I'm right in saying he used these orgone accumulators, and these things would have channeled this stuff. He would have observed the same effects as Ken Scholes, I'm sure. This is eternal technology, and as I said, this is how you fix the sign-up problems. Sorry, the sign-up problems with what? The sign-up problems with the Martin Fleischmann Memorial Project? Let me know if you're having a problem with that specifically. You can log in and so on. You couldn't sign up to Quantum Heat. Okay. All right. Well, I'll do some tests and find out what the challenge might be. It might be it likes real emails or certain types of emails. Okay, so and then otherwise, if you just go to if you open the document up here, you can certainly sign directly into make a request if you want to contribute to the document here. Please be respectful of the work that's been done, and I think I've added some stuff in. Oh no, it's across a page. That's fine. And bearing in mind there is a edit history, so if you want to destroy it, then that's not good form. But no one's ever done anything like that. But the edit history is there, so you can't get rid of it actually. And yeah, so you can work in that basis in the interim, or maybe consider commenting on remote view or even on YouTube. And I think it's going to be community voted for. That's the intention. Yeah, definitely need to get you signed up, Mescal. Thanks, Corky. I was for such a long time I was toying as to whether to put some analytical stuff into the book, but I just want the book to be an art book. And it's just like, ooh, isn't that pretty? Isn't that pretty? Wow, how did that happen? And for people to be curious about how such an incredible natural work of art was created. And then hopefully that inspires them to consider looking at the companion book. So it's kind of like, yeah, it's a 1-2 on the coffee table. One is the pull them in, and then the other one is what is this? And then they'll have like little pictures or sections of the big book pictures, and then the analysis and then the hypothesis and stuff like that. Okay, so I'm gonna have to go pretty soon. So I really thank you guys for your contributions, for your sorry, just to answer, I didn't finish answering Lou. He said that it is everywhere, and yes, it is related to sunspots. Okay. Yeah, David, we're going to crack this open. Absolutely. And I was thinking actually probably better the X123 only goes from 1 to 40 EV, which will certainly we need up to 2 kV. So it's not really appropriate that silicon pin diode one, but it might be better to have a spectrometer like the one I have even. Because that does go down to 200, so if you can see a shift towards the blue, then you might be getting the right regime. And again, with one of those thermal imaging cameras, if you can see your anode getting colder rather than hotter, then you might have got to the right regime. It's midnight in London, but it's 22 minutes to 2 where I am, and I've got to be up early in the morning. I have considered. No, I haven't considered, but I will consider it. Initially, I wanted to do the small run for the Kickstarter. Well, maybe it's a large run, but like I say, the photo books are expensive. They're going to cost about 40 euros to make a piece. They're on card sleeves and stuff, glossy cover and so on. So I want to use something that I can lay out and just have that way. But if it becomes something that might be interesting on a bigger audience, then it would make sense to do a larger production run. But yeah, I mean, we can discuss that, Elias, and really thank you for that offer. The other book may be even better published. It may just be black and white. This is the combination that I'm thinking for the Hutchison books is one color thing and large format and just what happened, and the other one would be the sort of how it may have happened and what you can observe analysis wise. Well, that would be even better. That would let's have a conversation about that. With the process that I was going to use. I was going to use Mixbook, so you can see the scale that I'm talking about. I'm in the moment. I'm in Czech Republic. The other thing is I will be going dark probably from Tuesday. So after the launch of the Kickstarter, I'll be going dark for about 11 days. Because I want to kind of try and do the proposal for Fukushima. And I kind of like, with 2 big presentations, other things I had to deal with, the presentations I wanted to do anyway, and things like today, and getting the Kickstarter in my head right. I haven't been able to focus on that, but I want to focus on that. So if I don't see you, other than maybe just something about the Kickstarter on Tuesday and you're not there, I want to say wish everyone a very happy Christmas and and a happy New Year, and I hope that it brings you all the joy. And I think that O'Day is getting close to being with us. When we've got major universities and major governments funding this at the scientific level, and then you have papers like the 2 that I've read today, which really, that second paper, it was a bit of magic reading that with you for the first time, and seeing that they've got the solitons in there, the phallicosolitons, and that they have the magnetic charges, and the longer they are, the longer they last, and this all explains what we observed in Lion. 100% the Lion reactor is a quantum coherent nuclear reactor that you can replicate. It will be able to be replicated. Basically everything is out there in the public domain, and you will see these effects. You just have to care to look and care to do it, and that's it. We failed because we got the temperature wrong, and so did the other parties that attempted early on. It works, and it works in all of the ways that Solin observed. Okay. Thank you for being with me through this year and for supporting the project. I would ask you to ask anyone that is not subscribed to enough YouTube channels that please, let's try and get us over 4,000 by the end of the year. And if you feel like learning more about this material, please look at subscribing to remoteview.icu and also to sign up and contribute where you can in commentary or analysis or in experiments over at quantumheat.org. You can follow us on Facebook and Twitter, where most things within the field that are of interest and plus our own work is posted on a regular basis. And I look forward to a fantastic 2022, and I would like a electrical generation system that can also be used as a heat pump to join the simple experiments of HHO, which I believe that we have proven in over the last several years, and particularly in the form of AMASA. Vibration systems in the form of AMASA, but particularly in the simplified form of the ultra experiments, in the form of heat generation, specifically in the Lion experiments, but certainly all of the key features of quantum coherent nuclear reactor. And so I would like to add this kind of plasma type technology with the incredible things that it has to potentially offer to the table, and try and bring that down to very, very simple experiments. The Vega experiments has shown us so much over the last year, but for me, those two videos in late October, early December last year, when I saw them, I thought, this is done. This is just done. It's just dotting the I's and crossing the T's. So hopefully it helps people accept that this is a reality. And that there is maths and science behind it. There's a long history behind it, and that what we have seen across multiple systems with hydrodynamic systems and magnetohydrodynamic systems, these things are real. Exotic vacuums are objects are real, and they are the key to Lena and the future of man. So with that, I say thank you, good night, dobre noc, buenas noches, bon nuit. I'll see you later.